I think so. And this is nice. And I will do 1.5 here, and I will do 1.5 there, and I will do 1.5 here, and I will probably do 1.5 here, and demo. Then is it? I think. And let's go to edit first. Edit it. Remember. No, not yet.
Hello.
Yes, Ananya, I can hear you. Can you hear me?
Yep. Hi.
Wonderful, wonderful. Okay. Ananya.
Wait, sorry, can I go get my iPad? Sorry, 2 minutes.
Sure, sure.
Hello.
Yes, yes, you're back. Hello, hello, testing. You are back?
Yep. Hello.
Yes, yes. Okay, all right. You said that you're taking your iPad. Then where are you zooming from?
I call from my laptop, then I use my iPad to do it.
Yeah, that's good. That's great. That's great. Okay. So Ananya was looking at our Jamboard, and we basically did reach the end of the Feynman diagram thingy.
Yep.
Regarding there's the quark changing, from down to up and all those stuff. Blah, blah, blah. Right. How do you feel about that topic?
I think it's okay now. It's a lot better than like when we started.
I guess I'm glad to hear that. Right. Okay. Because that would be what you would need. That is probably as far as the exam will take. Right.
Yeah.
Sorry, you were saying?
No, nothing. I agree.
Yeah. So I remember that you have a practical problem, like you don't have much paper to practice with. Am I correct?
I'm not sure. I think I have past year papers, like a few school ones and stuff.
That would be very helpful. At this point, wait. Let me think for a while. At this point, you have covered all the week topics, you think, right? Something like that?
There's one more actually, astrophysics.
Oh yeah. Oh wait, we need. Oh,
Yeah.
that one we need to. Right. You, it's it's not too much if we just talk about it starting today. We probably need two or
Yeah.
okay, sure. Right. You send me the slides then, as usual.
Yeah. Okay.
Okay. And
I sent on WhatsApp.
oh yes, please, WhatsApp. That would be great. And Keiko, I can see you also. Can you hear me?
Yes.
Right. Wonderful. Okay, Keiko. So what's up? Tell me.
What's
Yes.
I did a bit more bio this week. I did one math paper yesterday.
Sounds good. Okay. Are you happy with your third week? How'd that go?
I think it was okay. I'm not too worried about bio now, I think.
That's good. Yeah, I was feeling that it's a little bit of a blur because yeah, but it's just because you haven't got into doing it. That's what I feel. So yeah, good. That's good, right? Nothing surprising. It doesn't mean that that's to be for granted. Like I like that a lot. Good.
Yeah, I think for next week, right, I'm gonna focus mostly on chem and bio. Math, I'll just dedicate one day to it. The lead day, I will shift it to. Okay, so on my actual exam week, right, I have 2 days of like nothing before lead, because lead is on a Friday, right? Then Thursday, Wednesday is like nothing. So I think I'll just shift the lead day to.
Yeah,
that's,
yeah.
I mean, it's lower priority.
Correct. It's obvious, right? That you settle everything lah. That means all H2 first, all H2 done first lah, right?
Yeah.
And for the H1, you have 2 days, which is more than enough now. Come on. Yeah, I mean, in proportion, right? Yeah, nice. I like it. Ananya, I'm just reading your slides in the meantime. I like the part. I think that's very clear, right? Very, very clear. So today you want to talk about what?
I thought we still have the 2 math questions.
Let me see. Wait, am I forgetting something? Wait. Oh yeah, you settled the 7 mark thingy, right? Okay, I like that a lot. I haven't asked whether is that bothering you or not.
The differentiation one, right?
Yeah. That's probably the hardest thing they will give you lah. If you understand that,
I mean, I get what they're doing.
Yeah.
Like I think I mentioned on Tuesday was like simultaneous equations.
Yeah. Which I hope now mentally you wouldn't be surprised lah.
Mm.
That's what we need to do, yada yada. That's what they want. They will do if they want to make things more, entangled and complicated, right? Good. I like. So let's say that for this paper, that differentiation question is one of the harder ones, lah, right?
Mm.
Always a 15 marks of trouble, right? Trouble. Oh, good. Okay. What is left is the vector question, right? I mean,
Yeah.
I tried for part one. I'm not really sure whether I phrase it that way, right? But like that. I'm using the plane to argue. It's more like an argument. It's a bit weird. I'm doing that. Doing any mathematical proof, right? So I guess we're left with part two, right?
I guess, yeah.
Yep. So, you have anything else? Please do put them, yeah. For now, I'm reading the first few slides, and those are very nice and interesting curiosities lah. If you like those things, you will like. If you don't like, then it's an information, right? I'm currently at astronomical unit and light year. Pretty simple stuff at page 19, right? I'm at page 19 already, right? Can I just confirm that you have any trouble or not from page 1 to 19?
I'll go read first and let you know.
Oh, sure. Right, okay. Right. 1 to 19. Okay, cool. Yeah. Oh, I'm surprised that part 2. Oh, really? Yes. So perhaps part 2, I'll try drawing first. So, I mean, we always have the concept that this is a very abstract thingy that requires a lot of like mathematical mental gymnastics, right? Right. I try to pretend that it's not like that. I don't really know what's going on here, but if I could draw it, for example, I will go ahead and draw it and find inspiration. It works around 50% of the time. The other 50% is really algebraic gymnastics. So then I have not I have to face it. Before I face it, I'm hoping secretly that I can solve it by drawing stuff. Okay, that's what I'm hoping. I can see S cross T not as a very weird thing, but for example, it can be seen as the plane. It can be. The other option is it can be seen as the normal. You think it? Yeah, makes sense, yeah?
Yeah.
I'm gonna draw the normal, right? So the normal here, which is S cross T, right? Okay, just gonna do that first, right? And find some inspiration, because drawing the plane is usually not I will do, but since the S and the T is on the plane, right? It's on the plane. So S can be randomly here, right? And then T can be randomly there, right? So at least I try to draw that, right? Okay. So he's saying that this guy S dot the normal, right? Dot the normal will be equal to 0, meaning that they will be 90 degrees to each other, right? And so that first part should be obvious to both of us, yes or no?
Yes.
Okay.
Yes.
So the explanation, I don't think I will go to algebra. I use, argument. No, like normal is 90 degree to the plane. S is on the plane. So S and normal is 90 degree. Therefore, okay, equals to 0. Okay, done, yeah? That one's done. Yeah.
Okay.
Right, that one shouldn't be part of the problem. Then it should be used for hand. So let's say hand show that equation blah 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 is maybe written of the dot product, right? Dot product. Okay. Normal is S. Oh wow. Okay, right. Which is what we do every time. That is what we do every time.
Yeah.
I'm still tempted to use some sort of drawing. So I'm going to do that first. Okay, so it helps me that this is 0, right? That's the 0, 0, 0 point, right? And then I will put a random point A on the plane, right? Again, I'm secretly hoping that the drawing will help me secretly, right? So here's my A, okay. Just to be clear to myself, the R is, well, the R is every possible point, the vector of every possible point on the plane, right? That's what R means. Would that be okay?
Yes.
Good, good. So now, why would he even tells you that normal ST, right? He did actually tell you that, right? So do I go algebra or do I go drawing? I have no idea, right? And you tried the algebra method and you have the first line with you. Am I correct? How does that help? I don't know. Let's try. Ananya, are you okay so far?
Yeah, I'm at slide 19.
Right. So how does it feel for you from 1 to 19?
It's a bit abstract.
I guess we don't have the opportunity to observe all this. We really don't in Singapore. It's terribly difficult. However, all that he's been trying to tell you is that there are stuffs in the galaxy, not in the galaxy, in the universe. Oh my goodness! Now the thing of it, he tells you a lot of things, isn't it?
Yeah.
Oh yeah. What can I say except that they will feel random to you, right? Okay, there are two things that must not be random to you: AU and light year. Are those things okay?
Yeah, they're okay.
Let's pretend that the rest are there for our enjoyment first. Let's just pretend that, okay? If we need to come back to it, we will. Parsec. There's one more parsec. Oh my goodness, parsec is going to be important, right? So in slide 20, there's parsec.
Yeah.
Will seem very abstract actually. Ping pong, ping pong, ping pong, ping pong. The issue is what they will call the parallax angle. The parallax angle, I think, will be in a slide later. But the fact that he declares 1 parsec is 3.26 light year seems easy enough to understand. That one can, yeah?
Yeah, that one can.
The issue is the parallax angle and what the heck is 1 arcsecond, right? Okay, later lah, we'll see. I'm gonna ignore the slide 21 for now.
Okay.
I'm going to really ignore slide 22 for now. Really. There you go. Parsec. There you go. Okay. At slide 23, parsec. This one we can I don't know. Depends on what can be. Can we ignore that? I don't think we can. The best would be, let me see. The best would be slide 27. Just a minute, I'm deciding. I'm just deciding
Yeah.
which one to comment. Which one is the fastest? That's not good. Yeah, to use a simplified one. So Keiko, you give me some time. Yeah. Okay. Page 17 Anyanya. I'm gonna just explain parallax, not using the stars. Parallax is something we experience on Earth. So let's go a bit, let's go a bit less abstract lah. So do you like traveling on a train or on a bus? I mean, I don't mean MRT. I mean like if you go to Europe, where the view is nice, train or bus.
Yeah. Train probably.
Right. Okay, let's say the train trip in Europe or Japan, and I think we meant when we go through the more scenic places lah. So yeah. So let's pretend that we're looking at a mountain. Let's say as we travel through the train, and these are the windows of the train. We are here. Right? We see a famous mountain far away. In Japan, it's slightly easier to imagine because it is a one big mountain, Mount Fuji, right? Mount Fuji.
Okay.
Sometimes it's a range of mountains, so I'll simplify things and just focus on it. The Mount Fuji is really like almost like a kid's drawing. You just draw a mountain and there you go, that's Mount Fuji. Now, Mount Fuji is very far from the train. How do we know? Because trains don't like mountains. Trains don't climb very well. So we see the mountain. The mountain is very big, but it is very far. The train does not try to go too near to the mountain because it has to overcome a lot of height, right? So he has to choose his route calling. So let's say that the mountain is very very far. And at one instance, you will see something like this. How do I have to describe this? And one instance, you see a very beautiful sakura tree. Okay, let's say that's what you like to see, right? Here's the sakura tree, right? That's the first second. That's one instance, and then as you speed up very fast, right? I'm gonna eliminate the window. Just imagine that you're looking through the window. Yeah, just imagine that for a while.
Okay.
By 1 second, you would have traveled quite a distance. A train is fast, right? So after 1 second, you would have traveled, I don't know, maybe 20 meters. I don't know, right? And 20 meters will be around here, maybe. Okay, this is u t0 and this is u t1 second. Will this be okay?
Yeah.
If you're still looking at the sakura tree, that means you would have had a different, a different angle over your head, because you like the sakura tree a lot. You will look at it, and then you will just slowly shift your eye and your head. You're looking at the same object. Yeah. Now, what is interesting is to explain parallax is the thing you see behind the sakura. The thing you see behind the sakura at t equals to 0 is very different from t equals to 1. At t equals to 0, you will see the Mount Fuji behind the sakura. At t equals to 1, you will see, well, something else. Something else. I don't know. Let's say that it is a very nice, beautiful house in Japan. For some reason, they have very nice houses there. Something like that. This, in short, is parallax, and there is nothing weird about it. This is what we expect. Okay, let me put it this for a while. You can accept, right? If you keep focusing on the sakura tree, the thing behind the sakura tree will change if you change position.
Yeah.
However, the house never moves, the tree never moves, the mountain never moves. Nothing moves. It's you that moves.
Mm-hmm.
Because you move, you will see different things if you look at the same object. That is parallax, keeping it very simple, right? It's a fancy word for just what we see every day. That's just what we see. Okay?
Yep. Okay.
If you find this to be clear, then if you look at your slide of page, I guess the best thing is to ignore the guys. Ignore the slide with the guy's eye. Just ignore the your eyes. I would choose page 26. No, I don't like York. Okay, let's choose page 27. Okay.
Okay.
Page 27 is saying that you, as the observer, moves around.
Uh-huh.
Because you are on Earth, and Earth definitely moves around. In fact, he moves very far in 6 months, and in another 6 months, he will come back. So 6 months is the greatest distance you can ever move. Consider,
Okay.
right? So in 6 months, you move from one end of your orbit to the other end of your orbit. Okay.
Mm-hmm.
If you keep looking at one star, that will be your sakura tree. Because you're very interested in that star, suddenly things in the background is different. Not suddenly, I'm sorry, in 6 months, right? In 6 months. If you look at one particular star, the background of the star will be different in January and in July. Just like the background of our sakura tree will be different. Okay. Let's pretend for now that nothing moves. It is not true that nothing moves in the universe. That's not true at all. But in our eyes, they seem to not be moving, just like the sakura tree, the farmer house, and Mount Fuji. Just like that. They won't be moving. We are only moving. Because we move and the rest we assume not moving, the difference in the background, we can measure the parallax angle. We can do that by simply drawing a triangle. Once we have drawn the triangle, we have the angle, we suddenly have the distance to the star. It is simple trigonometry. The triangle next to that is simple trigonometry the moment you have the angle. Am I making any sense right now?
Yeah, I think so.
So the parallax, we make use of parallax, right, in 6 months' time to measure an angle. Usually the question will tell you, and then we draw a simple 90-degree triangle to find the distance from the star to the sun, basically. It's not actually the distance from the star to Earth. It will be very similar though, but just assume that it is the distance from the star to the sun.
Okay.
Right. And by the way, our orbit is considered to be, constant, just assuming a lot of things here. If you assume that our baseline R is constant, then, we have everything we need, something like that. That is what stellar parallax method is something like that. Okay?
So the baseline is constant, but only the angle changes.
Yes, and therefore the D will be able to change them.
Oh yeah, okay.
Depending on the angle. We will have to discuss the limitation of this method later. This method has some limitation later. You have to first understand the method, which is by looking at page 28, 29, 30, okay, 31. And I strongly wish we have a worksheet. Why don't we even have a worksheet here? We need a worksheet. Where's the D1 and D2 worksheet in page 33?
I have it. It's
Okay.
like spread. Okay.
Would you kindly read the slide? Make sure you roughly understand their simple trigo, and then do the worksheet before we move further. Okay?
Okay. Yeah.
Okay. Well, I'll see each other in Jamboard.
Okay.
Echo, since I'm still thinking about that, right? Can I look at page 3 first, right? Yeah. Okay, nice. Okay, tell me what's your problem with page 3, Kiko?
I think my approach was different from the one that they intended, or maybe I had a misunderstanding somewhere. I'm not sure, but yeah, cause I, like, if you see the diagram here, right?
Yeah.
Then where is that? It's known that the proportions of fair and good items are equal. I just interpreted it as 1/3, 1/3, 1/3. But I think that's not what they were actually saying.
No. Oh wait, yeah, because wait, because it's only fair and good. It doesn't include poor. So fair and good have the same area, but not poor. I would read that. If I just read the sentence, that's how I will understand it. Would that make sense? Everything will be either poor, fair, or good, true. But only fair and good are equal.
Then how would you do this question?
Let me think for a while. I think the drawing is probably fine, right? So let's see. So 50 standard deviation of 5. Then we have some idea about 45 and something like that. Okay. Then 44 is quite far. So oh wait, they already tell you what's poor, right? They tell you that poor is 44 and below. That basically means they tell you the area. What?
Poor is 44. Wait, again.
Okay, wait, this one. They tell you where poor is. Poor is 44 and below. This is not 1/3. No. It's something else. This poor part is something else, and they basically tell you the area by telling you is 44.
The area is 44.
No. 44 and below, right? That's the limit.
Yeah.
Since they tell you the limit and you know the mean and standard deviation, remember questions are always easier when you have mean and standard deviation. If you don't have, you go and find them, correct?
Yeah.
They have already. So if you have mean and standard deviation and you have 44, you know the area of poor. No way?
Okay, yeah.
No? Then the rest you just divide by
Okay.
Make sense? Make sense? I will argue that this is a reading problem. I will argue. Think about it for a while, yeah? Think about it and give it a try. Okay. Ananya, how are you so far?
I'm pasting a question in the Jamboard.
All right. I'll make it bigger, Ananya. Okay. This is the okay, sure.
Okay, I think I get it now.
Just a reading, right? So for Ananya, actually, I want you to focus more on B lah for now.
Okay.
That means you will be drawing it anyway. If it's something that it is not drawn for you, you will naturally have to draw it, or I would argue want to draw it. Okay, so let's see what you can do. Okay, go. That should settle it, right? Okay.
Actually, after this, I don't have any other questions for math, at least.
Wait, let me just confirm one thing about math. Does that mean that you are comfortable with the rest of the questions?
Yeah.
I believe you. I believe you. I would say that this is probably the most prepared you are right now for
For math, yes.
exam. And
But I
you,
mean, my bio and chem are a bit not as prepared.
correct. I would argue, yes. And you would be at peace to concentrate on both of them, and obviously also not literature. I would say that that is a very good mental state. You're not being unbalanced lah. Let's just say, yeah, correct, yeah.
Yeah, and I mean for lit, right? I think as long as I write something relevant and not out of point, I can still get a B lah, honestly. It's just closing the gap between A and B. That's the main problem.
I feel that it should be like that. I mean,
Yeah, I think it's like that.
I feel that therefore it is, in that sense, slightly more forgiving than GP lah. Maybe
Yeah.
getting A is a big, getting B is already a little bit uncertain, right? But
yes.
Literature, maybe you can go to B because you said that you haven't gotten much B lah, right? B is not a certain.
For lit, is it?
Yeah.
I mean, for last year's exams, I've been getting B's. My practices were not B's, but my exams were B's for some reason. So
no, fine. No, sorry. I remember it worse than, actually you already gotten B. So
yeah.
B should be a reasonable thing to do for now. Because you're achieving, it's not even maintaining, right? Because you're having the whole syllabus, right? Cannot say, but you are aiming for more for the other subjects. I think that's why it's reasonable, right? Reasonable. Yeah. And so therefore, if your math is at peace, your lit is okay, would you like to start on your chem or bio right now? Especially if you have not tried the what was that, the buffer thing?
Oh yeah, I haven't, because bio was taking a bit longer than expected, but I think the time spent on it was worth it. Yeah, like the last two topics, I finally understand what they were talking about.
Right? That's what we think was the best, right? We should go.
Yeah.
And that makes you feel better afterwards, right? Yeah. Again, being balanced, not unbalanced. So right now, the thing that is making you unbalanced in chemistry is that guy, right? We know. Why don't you just start now? No, just whack now, right? Just whack now. And no need to rush, okay? Okay, no need to rush. Okay, so for you, Ananya, you're drawing stuff. I like stuff, right? Yeah, and that's arc second thingy. Yeah, arc second. The arc second thingy. Ananya, arc second thingy. The arc second thingy. And surprisingly, could you just explain to you what arc second is, right? They do. Where is it? Come on, show me. Arc second. Wait, where's the slide? Yes, there you go. So they explain to you in slide 30, right? That 1 arc second is 1 degree over 3,600. That's what slide 30 means, correct?
Slide 30. Oh, okay.
Right. So arc second is a very small unit of angle, which is to say, again, 1 degree divided by 60 divided by 60 somehow. So 1 degree divided by 3,600, a very small angle. Okay. It's how far the stars. It's a bit of a stretch already. I cannot imagine what arc second. You also cannot. I cannot even imagine how they measure it. For good or for bad, they are not asking us to measure it. They're just asking us to accept their measurement. I have difficulty imagining how they measure that accurately. I have. I have very great difficulty, right? But apparently they can, the astronomers, right? So, okay, sure. Now, that means in your working, they give you their measurement of 0.549. That needs to be 1 degree, but over 3,600, right? Because 1 arc second is, that much.
Mhm. Okay. So how do I calculate it?
One more time, so 0.549, not degree, right? It's not degree, but it is 0.549 times 1 over 3,600 degree. A very small degree indeed lah. Indeed, that's what arc
So
second.
that would be the angle.
That will be the angle, right? If you want to use any tangent in degree, I guess, then if you want to, then you will use that. You will use that. So let me see whether you're
Okay.
size on you, whether you need radian or not. He does not. Wait. Look at this. So look at this thing. So there's another math stuff going on here. So I'm just gonna leave it to you. Right, there you go. This thing. Okay. Now, for very small angles, tangent P equals to P. So far,
Yeah.
good, right? Now, this is great for two things. The angle is always very small for this kind of measurement. It's just extremely small. This is small enough. There is no case where it won't be small. On Earth, when you're looking at the Sakura tree thingy, it's not small. We have to use tangent properly. But right now, basically this means we are free to use P all the time. However, the P, he doesn't seem to clarify. This only works if the P is in radian. It cannot be in degree.
Oh, okay.
So you still have to convert this degree into radian, and then you are free from the tangent, because tangent P will be approximately P in radian.
Mhm.
Can you convert degree to radian easily?
Pi over 180 or something, right?
Something like that. So you have the degree, you convert to radian, then you use that for P, and then you get your small d.
Okay. So in degrees, it will already be really small, but then when I convert to radians, it will be even smaller.
Both is equivalently small enough for you to ignore tangent. However, mathematically, you cannot approximate tangent P equals to P without converting to radian. Not discussed here. It is totally not discussed here, and very strangely speaking, it is also never discussed in math. They just tell you that that's true.
Okay.
However, you can actually see this in calculator. You can. If you try something like this, you just humor the math for a while. If you take your calculator and set it to radian, let's say, if you put tangent, a very small radian, 0.005 radian is considered very small already. This is like way bigger than what we're dealing with here. You see for yourself, tangent 0.005, isn't it simply equal to 0.005? Just give it a try. In radian though.
Okay. Okay, I try.
Yeah, try. But that is true in radian, and that is not true in degree. Give it a try. Then you have less doubt about what's going on here. Tico, are you okay so far?
So tangent 0.005 in degrees would be almost equal to 0.005 radians.
Sorry, what do you say? Sorry.
Can you repeat the 0.005 thing?
Okay, wait, I can do that by, wait, let me just set it up first.
Okay.
Um, okay, nice. Wait, what? Okay. Wait, let me just confirm something first. Okay, now I'm sharing you my screen. Yeah? Okay, Kiko, you can ignore for a while.
Okay.
Share my screen. Share my screen. Okay, Ananya, you look at my Google. Okay. Okay. I have a simple thing. Yeah. Right. So I have tangent 0.005 radian. Okay. The result is 0.005 with a very small number following. This is what they mean by the tangent of the radian. It will be equal to the radian itself, approximately. Okay.
Oh,
However, if I change it to degree, I'm doing that right now, right? I can just easily do that. Tangent 0.05 degree. It is not equal to 0.005, simply put.
oh, okay.
But if I again do it in radian, okay, in another one, a random number like this, 0.0010, whatever, in radian, okay, what should this result be? Well, something very similar.
Yeah.
Again, if I change it to degree, it is not the case, simply put.
Okay.
So, is the math okay, Ananya?
I think so. I'll try doing the question again.
Sure thing, sure thing. The last thing you have to worry about is the light year. So that will come very soon. Let's see. Just to confirm, Geko, you are...
Yeah, I have something to ask actually. Wait, just need this to.
Wonderful. This is a
Okay. So
a week, right? Yeah, it's a week.
yeah, the other time we discussed like about the weak acid dissociation and all that, and because there's that weak acid and the fact that it's able to dissociate, that's why there's a buffer like for this one lah.
Dissociate slowly lah. Right.
Or I mean like able to like reversible or something like that lah.
Yeah. Keep certain things in storage. It doesn't just throw everything out of the window.
Yeah.
Yes.
And then for this one, the weak acid, weak base, because there's no like strong acid or strong base, then no buffer can be formed. That's why this thing increases like steadily, right? The pH.
Okay. Again, technically there is a buffer in region 2 and region 4. It is just more complicated because there's storage of the H and the OH fighting against each other, and it does weaken the buffer. It does. It make it less buffery because a buffer, they don't tell you this. They don't tell you a lot of things, right? The definition of the buffer that it has to move very small over a certain wide addition of OH minus.
Yeah.
But they never tell you strictly speaking, because to be fair, it's more like a convention. Now, that convention, which is not told to you, just told you what buffer is, weak and strong and weak, is still present here, but in a less pronounced way. And the syllabus seems to me, it seems that the syllabus is just not interested in talking to you about it. He just skipped over the issue. You will never see this in exam also, at least that's from my experience. So what I'm trying to say is that there is no quantitative stuff here in week and week. If you ask me qualitatively, yes, there is a weaker buffer going on. There is. But quantitatively, what are you supposed to do, and will the formula work? Simply put, you can assume that no. But that's because you probably don't have to deal with this. Would that be a satisfying answer? Just qualitatively take it So, you know, just a nice thing to know right, for now.
Then, oh, why? I'm not sure if we've discussed this before, but why? How come this one doesn't like increase much? Like it stays quite flat before it suddenly shoots up. The strong base and strong acid, strong base.
There is nothing mysterious in it. It's really not. I told you before, and I want you to try to imagine it. I really want you. Okay, so we start from the strong acid, strong base is being added. So remember, I told you that the issue is the logarithm scale, right? The logarithm scale. Remember, I told you that if we start from, okay, sorry. So pH 1, I really asked you to think about pH 1 as 1 in 10. pH 1 is 1 in 10. Right? Yeah, you're quoting the formula. If you could bypass the formula for a while, do you agree with me that pH 1 is 1 in 10? If not, then use the formula to confirm that it's 1 in 10. No? It's like 1 H plus ion among 10 water molecules in average. That's what we
Like
will,
that, right?
yeah.
Okay.
1 is -1. Then the concentration of H plus is -1. What does that mean? 10 minus 1. Oh, 1 in 10. 1 in 10. Okay.
Okay.
Now, furthermore, I will ask you to imagine that there isn't 10 H2O, there is 10 million H2O. Okay, so 10 million H2O is what we have to worry about right now. The reason is because there's so much more water molecule than that I guarantee you, but we only have to worry about 10 million because that's where you hit 7 low, pH 7. Okay, so that's enough for our imagination. So I have 10 million with a lot of zeros, and I have 1 million H plus. Right? That's pH 1. This be okay first.
Yes.
Going to pH, right? pH 2 is, what is pH 2? Again, we have 10 million, right? Water molecule, that does not change. I have how many H plus are we talking about here? You think about it for a while, Kiko. Ananya, you seem to be getting it, as in the answer, but do you get?
I used different method. Plus, the angle thing was really confusing. I don't know if I was doing it correctly. But it gave me like a really weird small number.
Okay. So let me explain to you. Again, when you were doing the basic trigo, they will give you an answer which is more like in meter. They will not give you an answer in light year. Okay, if you do the pure tangent in radian, that is the pure math going on, and it's going to be SI unit, and therefore SI is meter. And the point is, it's not going to give you light year. So far, so good.
Yeah.
There is now a cheat sheet, a cheat super shortcutty thingy. If you just ignore the arc second, meaning to say, I'm just gonna use 0.549. Okay, in the assumption that tangent P equals to P. There you go. This is our tangent P is going to just be in radian, right? In radian.
Okay.
If you do that, just put in the 0.459, the astronomer give you a very nice shortcut. He will give you a value which is not in meter, but he's going to give you a value in light year immediately. It's just so nice that way. So nice that way. So you don't have to do anything to the arc second. Just use 0.449, 3.26 divided by that. You will get this value, but in light year. And that's a very nice and simple way of doing things.
Yeah. Okay.
That's how they explain it in this slide, which is, where is that? They say, long story short. There you go, in page 29. Okay.
Yeah.
B in parsec means 1 parsec will be 1 light year. That's a lot of weird. If you believe me, then you'll always be correct. I'm just shortcutting everything here. They're just trying to tell you that, okay? If you use the arcsecond just like that without doing stuff, he will give you like, yeah, why so difficult in telling you that? Why so many slides to tell you that? I don't know. Like that, like that. That's the simplest way because they're trying to make our life simpler, not complicated. The slide is not achieving simplicity. There. Show you what you need to know, and that will be correct every time. Yeah.
Okay.
Nice, huh? Okay, nice, good. And the 6 marks is, if you need my help in the 6 marks, okay, they I guess they do like to ask you that sometimes, you know, just define parallax angle. If you don't understand how the slide will help you, I will help you for the 6
No,
marks.
it's okay. I'll just draw the same diagram, right?
Yeah, same diagram, and then you have you have to explain the angle is this, the d will be in parsec, this orbit, sun, you know, sun here 6 months later there, and then you can code the formula and you can code the unit, and you will you have the 6 months.
Okay.
How is it measured? Remember, I told you that you don't actually really know how it's measured, but drawing the diagram will give you the will give you know, an illusion that we know. that's the illusion there. We don't really know it, but we just draw that, and then the examiner will also agree to that. It's our social contract. Say it that way.
Okay.
Yeah. Kiko, are you okay? Yeah, that will be the 100,000 thing, right? Okay, can, yeah. So this will be 900,000 reduction, right? 900,000 reduction. You need 900,000 OH minus lah, molecule, right? To achieve that.
Yeah.
So now I'm gonna let you imagine there is no buffering, there is no buffer that works in pH 1 to pH 2. No such thing, no such thing. Whatever the reason is, the buffering will always happen in between pH 3 to pH 5. More usually, preferably around 4 to 5. Buffering never happens, as far as I can tell. I'm not a chemist, you know, but as far as I can tell, no buffer happens between 1 to 2. None whatsoever. They always happen in the weak one, and we are interested in that because that's where living organisms and protein are, you know, best functioning. Like,
yeah,
you must correct me if I'm wrong, but 99.9% of our enzymes will work best at those range of pHs. For 4 to 5, or at least 3.5 to 5.
I think so.
I'll be generous here. I'll pretend that the buffering works from pH 3 to pH 5, right? Okay. Which is where we'll buffer, and the mirror opposite when we're dealing with pOH. Okay? Just the same thing. Okay, that's where the basic buffer thing. But for some reason, again, organisms like us will prefer the slightly acidic thing. That one I'm not really sure why, but that's how we are, right? For now. Again, over 10 million. So you tell me how many are we dealing with here? And then how many OHs do we need? Ananya, are you okay? Oh, you're doing the other one, right? There should be at least another question, right?
No, there's no more about.
Really, there's no other question here. We are sorely lacking in practice, right? Wow.
Yeah, kind of.
I don't know how we work. Which probably means I just have to give you more, right? But right now I don't have, right? For now, you only have my promise to rely on, that I promise you that whatever the question about parallax angle, it'll just be this simple. That's a promise.
Okay.
We will have to go to the paper to see whether I'm, you know, bluffing you or not, right? Same thing with the Feynman diagram, all those abstract stuff, right? Okay, so if we're happy with that, for now, we just go on to the next part lah, the luminosity and apparent brightness. That will be more complicated. Starting page 35.
Okay.
And we're gonna totally ignore page 35. Ignoring page 36, ignoring page 37 for now. My goodness, what okay, sure. I mean, 39 is correct. 39 is correct. Let me just see them. Would you please just go to the point? Come on, slide. Come on, slide. Go to the point. Oh, okay, there is something that you cannot ignore. The something that you cannot ignore is page 44, 45, 46, 47. Okay, so until page 47. So the minimum that you have to understand, you cannot just brush through it, is 44 to 47. You can read the things before that for your information. But 44 to 47, if you don't understand, let's talk about it right now. Okay, give it some time.
I'll read from 35 to 47.
Yes, but 44 to 47 is what you really need to worry about. Okay, so sometimes there's no rush here, right? So this will be 9,900. There you go. 10,000. Yeah. Okay, great, good. So now, let's see. Okay, cool. Okay, repeat your question again. Yeah.
I asked why there isn't like much increase.
All right. Okay.
Yes.
So, in absolute terms, I just give you the absolute term. pH is not absolute. Absolute means, a more linear scale that we're used to think about. Logarithm scale is not very fun to the brain one. It's not fun. Like, for example, we forever cannot understand intuitively why pH 1 to pH 2 is totally different from pH 3 to pH 4. Like, it's just totally different. I'm trying to illustrate the total difference, because if you don't understand that, then nothing makes sense. And yeah, okay. So in two things lah, in pH and in earthquake, we don't live in an earthquake zone. I'll pretend that you want to go to Japan and live there one day. Oh, Japan again. Okay, Japan for you, Ananda, and Japan for you, Keiko. I mean, your name is Keiko, right? So you go to Japan,
I mean, I was literally just thinking about that just now.
Yes, go to Japan, right? Just don't choose Fukushima, because Fukushima is very nice, but you always have the lingering fear, yeah. But the people there is fine, Fukushima. Okay, so you go to Japan, okay? You go to Japan and you experience earthquake on your first day. The earthquake is earthquake 5.5. Okay, you decide to stay there because 5.5 doesn't feel very bad. Really, it is not bad at all. It's very normal in Indonesia. You're Indonesian with a Japanese name. Wherever you go, Indonesia or Japan, you will have earthquake. That's you lah. Hey, then you stay to Japan in another year, you experience a lot of minor earthquakes, and one particularly stands out. It's called earthquake 6.5, from 5.5 to 6.5. It doesn't feel like from 5.5 to 6.5. It feels major and minor. Minor as in minor inconvenience, 5.5. And 6.5 is where people really start to react. People duck, people go to cover, people go to the bomb, whatever. People just go and hide because it actually feels very significant. Okay, it actually feels very significant. It's from 5.5 to 6.5. Along those minor earthquakes, there is one or two which is 4.5. 5.5 is like super, like the grandson of a peanut. You don't feel it at all, 4.5. And you don't seem to get why from 4.5 to 5.5 is right from the grandson of a peanut to a peanut. But from 5.5 to 6.5, it feels like a tree is going to drop at you. It's significant. Again, do you know why that is so? It's a log scale again. Do you know why?
Do I know why?
4.5 to 5.5 is times 10. So from a grain size of a peanut to a peanut loaf, times 10. But from 5.5 to 6.5 is also another times 10. It's not twice, it's not the ratio of 5.5 to 6.5, which is just around, I don't know how many percent is that, 15%. No, it's actually times 1000% times 10. The power of the earthquake is 10 times from 5.5 to 6.5. If 5.5 is small, times 10 suddenly becomes not so small. But 5.5 to 4.5 is already small, minor. You divide by 10. I mean, you get what I mean.
I think so.
It's nothing. However, your brain and my brain don't work that way. It doesn't work like it is not obvious to me or to you why 5.5 to 6.5 is going to be major upgrade. And you go to 7, wow. Suddenly things are very, very major. Like from 6.5 to 7, 0.5 increase is actually times 3. Oh, really? Wow. Suddenly the earthquake is 3 times stronger just from 6.5 to 7. It's totally not within our math brain one. You just have to feel it to know it. Okay.
Okay.
I'm talking about how the feeling of the earthquake will make more sense to us than the numbers of the earthquake. Okay. Earthquake is something that you can at least see the number and feel the difference, and the feeling doesn't correspond the number. Never, you will never. Just know that 7, we are in trouble. Just know that 6.5, you're lucky you're not in 7. Just know that. I don't know why that's true. Like that, because the feeling will tell you if you experience. pH, you cannot experience. You can only see the number. So that gives you a slight disadvantage if you're trying to understand. So I'm telling you right now, from pH 1 to pH 2 is 900,000 difference. From pH 3 to pH 5 is only less than 10,000 difference. Okay. Obviously, first of all, going from pH 1 to pH 2 will require a lot of bases, and yet the increase is only, from 1 to 2. Obviously, you will see a very low gradient. The run will be very big. The rise of 900,000 is shrunk into 1 scale. Come on. Whereas here, 10,000 is shrunk into 2 scale. It's very confusing. But that's one more time.
I think I understand.
Hopefully, because that's what we have right now. We cannot feel it. We can only roughly see what's the problem. So this slow increase of gradient is fooling us. The graph doesn't. The graph is fooling you. The graph is very dishonest in its scale. It is. I'm doing a lot of effort and you just register 1, really. Yeah. Now, as a bonus, I will tell you, obviously, buffering at this range, 10,000 plus minus, I'll just know it's actually 5,000 plus minus, correct? 5,000 to the left, 5,000 to the right. Makes more sense. You cannot buffer here anyway. You can't. Nothing can.
Yeah.
Okay. So in that sense, maybe we'll say, if you go evolution-wise, it makes more sense to have buffering capacity here because we can still therefore tide over, and nothing should live here because first of all, there's nothing to buffer anymore. Okay. Okay. Now, am I answering your question?
Yes.
Now that's the problem. We will always have the problem with the graph. We will always have that. Ananya, how are you doing?
I'm okay. I have one question.
Yes, please.
It's on slide 42.
42.
I don't understand how the rate of fusion determines the star's luminosity.
Wonderful. That one I can answer. It's so annoying. This is standard stuff. Why don't they just give you some picture? Okay, like this. Let me explain. You and I know that the sun is glowing because of fusion. That one's fine, right?
Sorry?
The sun is glowing because of fusion.
Oh,
And
yeah.
accept that. Okay, I guess we have faith in that. Okay, we believe what the scientists are telling us, right? Now imagine for what fusion means. Fusion means crunching things together, squeezing certain things together, and out of it comes energy, a lot of energy. The conversion from mass to energy lah. Okay, you really imagine it as an orange juice. You really do. You're squeezing the orange with your hand, and out come the juice, the luminosity, the brightness, the glow of the sun. So far, so good. Now, here's the thing that will now start to make less sense to our common experience. First of all, nobody can squeeze an orange as big as the sun. No hand will be able to do that, first thing first. Who is squeezing the sun in order to achieve fusion? The sun itself. Why? Gravity. The sun is already too big, so to speak, for its own good. The sun squeezes itself because of gravity. Am I making any sense right now?
Kind of.
If you believe that, and you believe that the center of the sun is the one that experiences the squeezing the most, not the outer one. Same thing with Earth. You know, the deeper you go, the more things you have above you, so to speak, the more you feel the squeeze. Let's just simplify it that way.
Okay.
So even in Earth, the Earth is squeezing itself, but not until it is fusioning. On Sun, the Sun is big enough, meaning it has enough mass that whatever the center is experiencing a very high level of squeezing by itself, therefore fusion. So far, so good? So
Yeah.
the core pressure law, like again, why is a pressure in the core? Because of gravity, everything is being squeezed in the middle, right? The more you have, the more you are being squeezed by yourself. That's the weird thing.
Okay.
The more the squeezing happens, the greater rate, or the faster or the more intense the fusion will be. Because as simple as you squeeze more, you get more. So greater mass will give you greater pressure, will give you greater rate of fusion, which will give you more light coming out.
Okay.
There you go. You have luminosity going from mass to luminosity. Luminosity is a fancy word for brightness.
Okay.
That is the qualitative way of saying it. Right. Do ask me more if you wish. Right. We have time. Keiko, are you okay?
Do we talk about this part of the graph? I can't remember. I recall my school saying that
you're wrong. That's not page 7. Yeah, bigger than 7. Sorry, yeah, bigger.
Yeah, I recall my school saying that like it's higher than pH 7 due to the hydrolysis of the salt, right?
Believe me or not, you quote the same phrase when I was saying last time. And
but then,
would you like the understanding it? Would you like it? Because
I understand the hydrolysis part, but I can't really seem to figure out where the salt came from. Wait, because this one is pH 7, right?
Yeah.
I'm pretty sure the salt is also there, right? But then for this one, it's like higher.
Yeah. It's not this. Okay, I'll start with something that will hopefully break through something. It's not the salt per se. It's not. Again, in pH 7, I bother to try to explain why it is pH 7. Remember, why is it pH 7? Because there is no extra H plus and no extra OH minus. You just have the salt. Let's be very clear. It's not a salt. It's one cation and one anion. The cation, which is, let's say, Cl minus, and the anion, let's say, I don't know, Na plus lah. the salt do not determine the pH 7. pH 7 is determined by, strictly speaking, no extra H plus and no extra OH minus. None of those are dominating. Cl minus and Na plus plays no part whatsoever. Again, they already say is pH. So you think about the concentration of H plus and OH minus first. Yeah. Now weak acid and strong base. In the equivalence point, the same thing happened. The H plus from the weak acid is fully supplied by the OH minus from the strong base. Theoretically, no H plus extra, no OH minus extra, correct? You're left with what in this case? You tell me, give me an example. Don't say the salt, but the
Na plus.
Okay, Na plus, let's say, and then the cation, or the anion will be?
Cl minus.
I'm sorry, what?
Cl minus.
It's weak acid. It's weak acid. Come on.
Oh, right. The ethanoic ion. Wait,
ethanoid, the ethanoid, right? This is the ethanoid ion, right? Okay. You don't care about this guy. Na plus never play a part. That's why we use it. Same thing with, Cl minus is a bit more reactive, but Na plus, Na plus is very happy, right? CH3COO is the cause of trouble. Your trouble, the trouble of figuring this one out. Again, you tell me. CH3COO is currently by himself, correct? By himself. What will he do? This is a test whether you understand reversible reaction or not.
He will react with the H2O. It will gain a proton from the H2O.
Yeah. You will draw the H plus, right? And then tries to balance to shift the equilibrium into forming
the acid.
H solid lah. It's not the acid. One more time. It's not the acid. This is because I'm contradicting.
Oh, the acid is the H plus.
It's always the H plus. However, yes, we call this the acid low. I know, but that's not very helpful. And calling the salt of the acid is not helpful. But that's what they do lah. And I'm contradicting the formality of what they're doing. I'm not contradicting the meaning of what they're trying to tell you. Okay. Again, you have to a bit shift from the formalities for now if you want to understand.
Okay.
Acid. This is the acid. This is an anion, which is an anion. And this is a solid, which is not a cation and an anion. Not an acid, not an anion. It is a solid. It is a storage. It is a storage away from the action, right? The action is in the So this guy will simply do its nature, do that. And the H plus will come from the water because there's no other option available. Remember, all the extra H pluses and OH minus are being, are being balanced already. This is the only explanation you need in your head. That's it. That's it. And you will use the K. The K, I don't know, whatever, the K of this reaction, the Ka, I suppose you call it the Ka, right?
Yes.
Use the Ka to find the pH done. Why are you using the Ka? Because this is the only thing that's happening in the equivalence point. This will happen. You know it. You have a lot of CH3COO minus sitting around doing nothing, and they will not be doing nothing. They will do this. In fact, they will seek to almost eliminate themselves, right? Remember? From 100%, they will seek to make themselves around 1%. This will be 99%. And by doing that, he will draw a lot of H plus to himself. He does not like to sit around.
Because
that's the nature of the reaction, which they're trying to impress upon you in all the K reaction. That is the feeling. This feeling is very important to you if you want to study chemistry in, further. This is the feeling to think about. By comparison, OChem is simpler I guess, to
I feel like it's simpler.
you just have to memorize, just like bio lah. Just memorize about it. The bad news is you have to try to understand something difficult. This is difficult to see in action. The good news is this is almost the only thing you need to imagine. For A level, for further one, you have a few chains and you have math to deal with it. It's difficult to imagine. It doesn't help, however, if in a basic level you also cannot understand. It doesn't help very much. This is the thing to understand. That's the feel. It's a feel, yeah. It's not a formula, yeah. Have I answered a little bit of your question?
Yes.
Give it a try, see whether that helps you or not, because people's need is different. Some people just, why bother, man? Just apply the formula. Well, they would be correct. Some people have a certain need to, imagine things. Let's say that's you, and here's the bad news. It's difficult to imagine. Still try lah. Ananya is not having an easier time. I'm asking him to imagine things that are also difficult to imagine. Ananya, how are you? Tell me.
I read through the slides. I'm a bit confused from slide 48 to the end.
48. Oh, you're at 48.
That's like a lot of new information.
Wait, you're okay with 47? Really? I'm very happy if you understand 47.
It's just following the formula, right?
No. There's an understanding that you will need here, which will be helpful later on. I think. Let me just check. Am I right? Yeah. Oh my goodness, the slide ends very quickly after that. I don't know.
Yeah, but there's two more sets of slides. I don't really like
why your slide doesn't. Why? When things are important. Oh man. You're saying that you're under the, oh goodness me. I'm not working very well with your slide. Okay, 48. Oh my goodness. Yeah. I'm annoyed. Okay. Let me summarize very briefly first what they're trying to say here, right? If I would ask you to see slide 51, they're still talking about the same thing, right?
Yeah.
Uh-oh, wait, what? Wait. Okay. So first of all, they didn't tell you the limit of the parallax angle method. Okay, I'm gonna Google that just so that I'm sure there's a limit.
No, I think they did actually, like in the previous.
Tell me.
Wait, let me find. I saw it just now. Slide 32, 31. Sorry, 31.
Nice. Okay. Okay. So 300 light okay. Whatever. You cannot imagine light year, you cannot imagine parsec, right? He's just throwing things around, okay? But
yeah,
understand what's 300 light year. We don't understand what's 100 parsec, but let's keep it in mind. So we can only measure 100 parsec, and for some strange reason, the last sentence is 500 parsec. That sounds like a lot times 5 until you realize that that is not a lot of things on the sky. How do I know? I'm asking you to believe me. 500 parsec is the sun of a peanut in terms of measuring whatever there is in our sky and our universe. It's really a very small distance. And this is already asking us to imagine something that we cannot imagine. A light year is so far, then 300 light years some more, and then you're asking me for 500 parsecs. That is, however, very small. Imagine that with the improvement. Okay, now improvement. Since the astronomers know that 500 parsec is small, not enough, suddenly they go and introduce to you a new method, which is whatever this weird thing called not parallax, but parallax spectroscopic parallax. Whatever.
Yeah.
Suddenly, we can go greater than 500 parsec. This is now 10 mega parsec. Mega is million, right?
Mhm.
So
Yeah.
improvement loss of 10 million parsec, whatever that means, compared to 500 parsec, whatever that means.
Mhm.
To the person who cares, it is a big improvement. 10 megaparsec is now a peanut low. We can measure a little bit more than a son of a peanut.
Okay.
And whatever that method is, he doesn't seem to, the slide doesn't seem to describe to you very clearly, right? Am I bothered, right? Why am I supposed to say, right? What am I supposed to say at the end of the slide? If the slide's like this, what am I supposed to say? Let me think. What am I... Okay, I can say something. So I'm gonna copy the last slide into the Jamboard, right? Just checking for Keiko. Are you okay?
Yeah, I think I'm actually able to make sense of the whole thing now.
Good. Now the question will test you. The question goes and complicate stuff.
Yeah.
Possibly don't do all the more complicated stuff first, but do something that looks medium and see whether you actually understand or not.
Yeah, I'm like referring to the lecture notes again to see if I'm able to understand.
Please do. Right. Okay, so Ananya in page 19, yeah? Page 19.
Mhm.
Focusing on this one first. Now, the Wien's law is the one, I'm not sure, maybe it's chapter 8 or chapter 12, I don't know. It's the black body radiation.
Oh, I don't understand that also.
Funny, same thing mentioned by Daniel, right? Oh, what the heck is that, right? Okay. Okay. That which you don't understand, right? That which you don't understand is being used here. Oh dear. Okay. Oh dear. It goes like this. The math is simple though. Let me just explain the math first. Although you don't understand Wien's law, you can understand one thing. I can at least measure the spectrum of that star coming to Earth. That star is extremely far, very faint, lighted, faint. However, if the star is naturally red, believe it or not, the star is red, not white. Most stars are not white. Right? If the star is red, then the red color will come to Earth very much unchanged. The red will travel to Earth as red. The blue will travel as blue. So far, so good.
Mhm.
Why does it matter? Because by using Wien's law, whatever that is, the color, which we can measure, we can only measure the color, right? The color, according to the law, will tell us the temperature. First thing first, we're converting color that we can measure to temperature, which we are therefore not measuring directly. First of all, how can we even measure the temperature of the sun, the closest star, right? I mean, everything will melt. We can't. We can only measure something else and then using a certain law, figure out what's the temperature. Am I making any sense of that?
Kind of, yeah. I think so.
The distant star is even worse. Right? We can even send something there, it's super distant, but the color will come. We get the color, we get the color, which we measure, we get the temperature. Why bother with the temperature? Whatever, this thing, which is, oh goodness me, you cannot do that. You cannot do that here. Why? You cannot. It's invalid. Okay, never mind. Oh my goodness. Whatever this thing, which is called the apparent brightness, whatever that thing is, we can measure the luminosity from we can measure the brightness from the star from where you are also. We can also do that. It's quite simple. Okay, we can measure the brightness. We can measure the color. Color gives us temperature. Combining the luminosity and the temperature will give us radius according to this formula. Look at this formula for a while. If I have luminosity, for pi and sigma, that's a Stefan Boltzmann constant. For pi and sigma is a constant. So far, so good.
Yeah.
If I know the T and I know the L, obviously I know the R according to whatever law this is. But I can know that. Mathematically, I can.
Okay.
Measure the color, get the temperature, measure the luminosity, put it in the formula, get radius. Why do we bother with the radius of the star? The slide doesn't tell you at all. He does not. He just tells you this random thing. To be fair, it's very random without context. Extremely random. But that is what you can do with your measurement. Why would you want to know the radius, the size of the star? For now, there is a mystery. Maybe we can write a novel about it. Okay, I have summarized your slide for you. It's full of gaps, and let's see what we can do with it. Okay.
Okay.
Sorry, that's I think how far we can go with your slide. We'll just have to jump to questions. Okay.
Okay.
We have 2 more minutes. Let's at least read a question. We probably cannot do it for now. Right? Probably cannot, but let's read it. Okay, go. Okay, so far.
The question in the slide, do I paste the question?
I don't think there's a question in the slide. That's a problem.
Okay, so I'll find the question about luminosity.
Yeah. Let's see how far the paper or whatever you have is gonna give us, right?
I can't add another page to the Jamboard.
You can't, but you have page 20 as your last page.
I do.
You do. That's the last page. I mean, Jamboard is limited to 20.
Oh, okay. Okay.
Keiko, are you okay so far?
Yes.
Good. However, I did promise this is the thing you want to understand, right? If you
I actually get it now.
If you understand this, that will be the key to unlock whatever. So, plus and minus, plus and minus.
So for this topic,
Yeah.
like including the whole solubility part, right, it's mainly just centered around the whole idea of equilibrium, right?
Or rather, how it goes from non-equilibrium to equilibrium. That means it's not the equilibrium, but the shifting of equilibrium.
Yeah.
You have to be agile in that way. Equilibrium is not one state. Equilibrium can be many different kinds of combination of concentration. And it can also be from a non-equilibrium to an equilibrium. If you can accept those things and think about it in that way, at least you will get understanding. Whatever.
Yeah, I think that's the main thing that I needed to finally get like the big picture.
Yeah. The promise is it will be, quote unquote, only that, right? It's a key. And the promise is it's every question will happen. So big stakes, but just one. If you focus on that, you will achieve some progress, I suppose. Even just focusing on that, you will see some nice things happening, even to the exclusion of other topics at this point. Even until that point, it's probably gonna be good for you. Net result.
Okay.
No more nagging feeling.
I think so.
Just whack that for 3 days. If that's what you want, you'll be fine. And then you go to exam with your OChem and all those stuff, right? And whatever transition method, whatever you have with complexes and everything, just whack them. You'll be probably happy.
I hope.
I will see you. So when do I see you? Oh, I'm gonna propose that we try a Thursday thingy instead.
Oh, okay, can.
I'll see you on Thursday.
Okay.
I mean, should be good, right? Should be good, right?
Yeah.
I'll see you on Thursday.
Okay.
Bye bye.
Bye-bye.
Ananya, this Cepheid thingy is what I'm looking for in your slide, and it doesn't exist in your slide. I'm
Yeah.
very annoyed with your slide. Okay, so hey, wait. If I'm annoyed, then you'll probably be very confused with the slide. Look. Okay. I will try just 1 or 2 minutes because we're almost done, right? But I'll try something, and then this will probably be the start of our next session, right?
Yeah. Okay.
Okay, so this Cepheid thingy is this is so annoying. Right? Okay, so look at the graph for a while. The graph in here, right? Now, let me tell you what this graph means. This graph is the apparent brightness, right? Well, whatever that means is the brightness that we measure from Earth. Pretty simple. Pretty simple. It goes something like this. It goes something like this. Huh? You know that a star is very bright light. For example, you cannot see the sun with your naked eye. It's actually very bad to do that. On high noon, for example, right?
Yeah.
However, there are many stars. There are many stars out there which are super gigantic and even hotter and brighter than our sun. Like wait. Okay? But they don't appear so bright compared to the sun. You know why?
No.
Because it's just like a how do I say this? Oh, it's very difficult. Okay. You have a table lamp for you for study.
Yeah.
That means you don't rely too much on your ceiling lamp. Yeah, correct?
Yeah.
Don't do this. Just imagine for a while. If you look at your table lamp directly, you cannot do it. Am I correct?
Okay. Yeah.
You are in the distance of around your eyes in the distance of around maybe we'll say 80 centimeter to 1 meter from your table lamp. Yes. And you cannot look at it directly. You just use the lamp to shine your table, and then you look at the table, right? Yeah. Okay.
Yeah.
Would you believe me if you try to approach your lamp, the brightness gets worse for your eyes.
Yeah.
But if you just go to your door, which is around 3 to 4 meters from your lamp, suddenly you can look at your lamp directly, so to speak. Would you try that right now? Would you, I mean, if you don't believe, if you could, you just try that. You just go further and then you look at your lamp. It's okay.
Yeah.
Okay. Now look at your lamp with your eye, and it's okay, right? Then you approach it, and then at a certain point, you stop where it starts to get uncomfortable. You shouldn't force your eye. Just be sensitive where at the distance where you feel uncomfortable, looking directly to your lamp. Or roughly where is that distance?
Like probably like 30 cm.
Really? You can go that close to your lamp, table lamp, really? Oh, really? Oh, wow.
It's not a lamp actually, it's like a tube light.
It's an LED tube. It's an LED
yeah,
tube.
yeah.
No wonder. It's more that way. Now, my question to you is this. The lamp never changed what? Your eye also never changed what? How come sometimes you can look at the lamp directly and sometimes you can't? Isn't that weird? If you think about it.
Yeah. So it's because of apparent brightness.
Okay. So that is the thing I want to explain. Oh, see, nice, right? Define apparent brightness, right? See, nice. Before Cepheid, right? Okay, nice. Okay, I'm gonna do that. Here's the reason, and then we stop here for now. If this is the lamp. This is the lamp, which is looks like a sun. this lamp will shine in every direction. I know your LED does not do that. Your LED shines in mostly in one direction. Let's pretend for a while that your LED shines in every direction. Okay, so at a closer distance, remember the photon will spread, right? The photon will spread, okay, from the sun. At a certain distance, all the photon, let's say this is 1 million photon. Can I say that? 1 million photon will be spread in this small circle. Yes. The photon then travels, and they all travel in a in an equivalent speed, and they will become a bigger circle. If that makes sense, they will spread lah. How many photon is in this bigger circle? It started off as a 1 million photon in this small circle. So in the bigger circle where they have traveled a bit, how many photon?
Lesser?
No, 1 million.
Oh, okay.
Nothing is absorbed. Just pretend for a while that you're empty space, right? In space, that's what happened. Nothing absorbs it. Hey, 1 million photon also, because obviously nothing is gone, nothing is added, right? In space. But it is a bigger circle. It is a bigger circle. And yet, if you go to higher distance, even bigger circle still, and still 1 million photon, correct? So the 1 million photon is now really spread. This is less spread, and this is quite focused. Make sense?
Yeah.
Your eye is small. Your eye is around this much. If you make it closer, it's also only this much. And if you make it even closer, that's the size of your eye. Can't you imagine when you are in the smaller ring or smaller circle, your eye is getting a lot more photon because the photon is just more focused. It's closer.
Yeah.
When you go further, you get less, even though your eye size stays the same, because the photon has spread. Let me draw for you the spread. The spread looks like this. So in this cone, let's say this will be 1000 photon, let's say, and this will still be 1000, and this still will be 1000. Therefore, here your eye will get around 500. Here your eye will get around 100, and here your eye will get around, I don't know, 50 or 10, I don't know.
Okay.
The distance from the lamp to your eye affects the number of photon that your eye accepts, because your eye converts photon into whatever signal your brain sees. Okay. So that's why you can see directly to your lamp when you're further. And that's why you can't when you're closer. You're getting too much photon. That is called the apparent brightness. The apparent brightness is the, so to speak, the photon, the amount of photon, percentage of photon that you get. It is not the real brightness of the lamp. The real brightness of the lamp never did change. Still lamp.
Okay.
That's apparent brightness in hopefully layman terms. Whatever you memorize, that will be the meaning to it.
Okay.
Then we can probably go to Safed. Okay, maybe next time. I have a question before we go. Yeah. So I don't actually ask you to do much extra anymore. You notice that, right?
Yeah.
I'm not sure whether you feel comfortable with that or not.
Yeah, I think it's okay. Like, I don't mind doing work if you want me to.
I don't mind either way, and usually I will lean towards not doing extra. Now, let me tell you the reason why. Based on my feeling, right? Is a feeling, based on interacting with you, I feel that you do grasp things reasonably fast. First thing first, right? The problem is right now we don't have much practice paper. If you have, you probably have practiced them.
I have actually no, I haven't. My physics. So like we have mini prelims next week once school opens.
Yep.
My physics exam is the week, like 2 weeks later on Monday.
Which means you will have to focus on a lot of other things before your physics.
Yeah, it's on 4th July.
Correct.
Oh, it's on Tuesday, sorry. Yeah, it's on 4th July.
Okay. But physics is H1. And I have
Yeah.
an impression that you are reasonably well with your other subjects lah.
Yeah. So for our physics exam, it's actually atomic nuclear particle physics, astrophysics, and energy production, and thermophysics.
Right, which I think in thermal physics there will be the wind thingy lah, right? So it is
Yeah,
true that
thermophysics is okay.
you're saying what?
Thermophysics is okay, but the black body thing.
Oh, the thermal physics is the one that we talk about the MC delta T thingy, is it?
Yeah, yeah, yeah.
And then the other one after that, like, oh yeah, okay, I get it, right? So if we are just talking about exam and this mini exam later on, obviously you and I are not happy with your preparation.
Yeah.
Imagine, if you agree, I will imagine that if we just take a regular time meeting, you'll probably, from after exam, just count the time after exam until your end of year IB, right? That final. We'll probably have being a bit positive, more than enough time to not just cover. Cover is not enough, to actually practice enough together.
Yeah, hopefully.
Set our goal in the mini exam. That's probably not what I have in mind. And I just want to make sure whether that is, conflicting with your goals or not.
Yeah. I want to like continue at least until prelims.
Yeah. So we just take it not slow and easy, but we don't take it like as if the mini prelim is like the most important thing in the world. It's okay. It's okay, right?
Yeah.
We just continue steadily and we'll do more papers, and then you'll see how far you can go but I'm not very worried about your state of physics if we have that time, which I think.
Okay.
Okay.
But I was wondering if it's possible to go through black body and all that stuff once, maybe on Wednesday, or maybe after we finish astrophysics.
Wednesday. So finishing astrophysics, because the slide is very weird, right? Okay, I don't think it will take another one. So let me think for one. Wait, let me just see the schedule.
There's like 2 sets of slides like after this. So I sent you one more, but then there's like one more after that.
Okay, so if you want one more, actually you can have up to 3 more if you really want to, right? In this, I have 3 more slots if you really want to. The slots, however, will be from 11 a.m. kind of 11 a.m. So it's a slot that you have not done before, but it's holiday, so probably you can do it.
Yeah, 11 a.m.
So you have Tuesday, Wednesday, or Thursday. You can have 3 of them if you really want to. To me, it depends on your goal for the mini exam. I usually don't bother student too much with mini exam. It's really the anxiousness of the student, which if you're very anxious, then go ahead and take it. You are usually learning very well in tuition, okay? So you will be productive. But if you want to take the long route, seeing it in more of a big picture, it's probably fine if you don't take too much, right? I'll leave it to you. What do you want?
I think for the mini prelims, I can just revise myself, so we can just stick to Wednesday and Sunday.
So let's say this coming Wednesday or 11, right?
11 or evening, both work. I'm okay with both.
Evening is probably not a good idea. It's more crowded already, the evening one.
Oh, okay. Yeah, so 11 is fine.
11, okay?
Yeah, okay.
Then we have another Sunday, right? We have another, which is next Sunday. And then that will be your exam already. Which
no, then we'll have one more. So this Wednesday, then Sunday, then Wednesday, then Sunday, then it's my exam on Tuesday. So we have 4 more.
But on next Sunday, after next Sunday, you will have to worry about other exams, correct?
Yeah, so I won't be like very, very focused on physics.
Please don't focus on physics. Like, please just focus on physics after next Sunday, okay? Yeah. Okay. I'm the type that think that you should just take the exam proportionally to the significance. It's not very significant. What is significant? Just continue to learn. To me, it's like that one.
Okay, yeah.
And I'll see you on Wednesday.
Okay, thank you. Bye-bye.
Hello.
Hello, hello. Daniel, can you hear me?
Yes, I can.
I can hear you also.
Shall we continue our math?
Yes, very good. Do you understand my reply first? Is that something important for you? The vector one. Have you looked at it?
No, it's in Jamboard, right?
Yep. Take it. Think about. Oh yeah. If you still want to continue with vectors, yeah. It ends up. I think it ends up touching something quite important. So that was in page 1, and that was in page where is it? Page 3. Yeah, 1 and 3. Slowly, please. Yeah.
So I must be making use of the cosine theta formula in question 1, page 1.
Definitely, you should be using that. There's nothing wrong with that. In fact, I say that you are not using anything wrong. You weren't. You weren't using anything wrong until the end. You were roughly, no, you were almost correct. That's the issue here. I'm going to some very detailed things here. I will try to explain it with drawing. Yeah, right. Is this important or not? Kind of, right? So when we draw the first vector and the second vector, remember cosine theta is an angle between the two vectors. Okay, we can't be quite sure until we get it now whether we get this theta or whether get the other guy. The other guy, we'll call it alpha. Just by flipping it a little bit, we can end up with either alpha or theta. Now, alpha will be quadrant 2, yes, more than 90 degrees, and theta quadrant 1, less than 90 degrees. Would you believe me? It doesn't matter what you get, whether you get 61 degree, let's pretend that the 61 degree, and the other one is 119, I think, 119 degree. It doesn't matter whether you get 91 degree, 61 degree, or 119 degree. Most of the time.
Why does it not matter?
Because if you get 119, there is 61 what? If you get 61, there is 119 what?
Okay, that's true.
It doesn't change the fact that the two vectors are the same, whether you get 119 or 61. The two different answers are not talking about, strictly speaking, two different vectors. We are correct on both answers. So far, so good? However, something might be confusing if you see the detail a little bit. Again, that one will stay true. That one will stay true no matter what. So let me give you an example. If the vector is this direction as this direction, let's say I will get 61. If I change the vector just a little bit by, for example, changing the direction. As you can tell, I mean, I know that this vector and this vector is strictly speaking not the same lah. One is, you know, pointing up and one is pointing down. That one is okay, fine. But even so, the angle should still be 61 and 119. So far so good, Ken?
Mhm.
However, one direction of vector will give me 61 and the other direction of vector through the formula will give me 119. And that we should consider to be the same thing. Did that make sense to you? Can you accept that first?
Yeah.
Okay, so now let me show you something. This one gives you a Q of -3, right? So now what happens if we do this? Right? Okay. Let's say I'm going to do something very similar to this. Right, look at that. Okay, -2 minus Q minus 1, right? But for some strange reason, I'm going to make this half, -1 and 0. Do you see the difference? The difference is only this is a minus of that, a difference of different direction. Would that be okay so far?
Mhm.
If I dot this, what will happen? You tell me, yeah? So if I dot that, what will happen? That would be equals to
-2.
-1. You mean -1? Correct?
Eh? Oh, it's a half. Yeah, sorry.
That's
-1 plus Q minus
0 lah, right?
-0. Yeah.
-0, which is going to be Q minus 1. The exact minus opposite of what you get lah. Because you know what? Because I just flip on a vector, I just flip it. Okay, I just flip it. If I use this, you will get equal to 5. Give it a try for a while. If I continue with this.
Mhm.
Okay. Continue with Q minus 1 downward lah, and you will see what. Are you okay so far?
Yeah. So just switching the 1 minus Q into Q minus 1.
By switching one of the vector, right? Just changing the direction. If you do that, you will get Q equals to 5. What does this mean? Both answers are correct.
But one is more correct.
One is what they want. One is what they want. Both will be equally correct. This happens in other cases where it's not very complicated. Here, they're complicating things by asking you to find Q. In reality, they will say, for example, show that the angle between the two vectors is, for example, 61 degree, and then you will find the answer is 119 degree. Wait, that's just the same thing as 61 if you just flip one of them, so to speak. That's what you will probably encounter in the other questions. I hope this.
This is not cross product, right? This is times.
That is that. I'm so sorry. Let me check for a while.
Should be times, I think.
That seems to be a times as a normal multiplication. a normal multiplication. Yeah, it's not a cross product. Yes.
Okay, that's great.
So the issue I told you, 61 versus 119 is just a normal thing when dealing with this formula. You will just keep that in mind, and hopefully it doesn't bother you. Instead, you can, navigate. Will this be okay so far?
I'm just sorting it out.
You do, and I hope that we will practice this in another question. Then you will probably
Wait, you said Q is supposed to be 5?
if you use the other one, if you use
Oh, it is. Okay,
yes.
okay.
So what's
Sorry.
there is nothing wrong. Let me repeat. -3 is not wrong. -3 is a perfectly good answer. But he wants 5. I am oversimplifying this, but yes, he wants 5. So we can easily give him 5 by flipping it.
Okay, just copy down a bit more.
Please do. Yeah, this is not this question only. Yeah, it's not. So it's going to happen again.
Oh no.
So try to start to understand it lah. More of that. You tell me when you're
okay. I'm okay.
The page 3, which is the plain thingy, is also important to understand. I tried a few methods lah. I didn't arrive this as my first try. Remember, I asked you to do something else and it doesn't work. Immediately I switched for another 2 methods. This is the third method I found to be working. That is a common experience to me in vector. We sometimes try a few methods. Please, first of all, understand why this method works first. It turns out to be not very complicated. I haven't done the full calculation, by the way. I haven't. I done the first few important ones. Do read it. If you don't understand, let's talk about it. Make it clear it's not this color. Sorry. Are you okay so far, Dad?
Darren.
Because other people is coming in. Let me confirm first. The first step, I change this form into the dot product form. Is this okay first or not? Then can you do it yourself? Can you actually change this form into a dot product form? That happens rather commonly. Danny? You have to do it yourself. Can you do it? If you can't, that's some trouble.
What's dot product again?
What's cross product?
Wait, what do you say? Dot product.
Cross.
What do you mean to cross product? I'm very confused.
Oh, right. I'm gonna delete all this and I'm gonna start with the drop. The wrong one, just delete. I guess that wouldn't matter. Here is the plane. Yes, let's imagine that that's the plane, right? In this case, it will be plane 2. Okay. Could you kindly draw the normal to the plane? However you see it.
Sorry, just reread the question. So you want me to make these two into the same form and then dot them together?
Put them together. Turns out not very necessary also. Turns out not very necessary also. But you must
How do I make this?
the second guy to the first guy. Yeah, you have to do that. I
How
think
do I make them the same form?
Yeah. So where's the normal in this plane? Where's the normal? Yeah, if you would. Yeah, nice. Okay, would you kindly draw that? Very nice. Okay, with an arrow and a normal and whatever not, right? Okay. Okay, now you kindly draw this guy and this guy. Where do you think this guy and this guy is in that drawing? Where should they be? So
I don't know.
It's a point, it's more like a direction, right? So let me be clear. In this form, let's call this the verse vector, whatever, v1. That's a verse vector. And this is the second vector, right? The first vector in that form will be on the plane. This is the first vector, pretend. Okay? On the plane. The second guy is also on the plane, just not parallel to the first guy. First guy and second guy will always be on the plane and, well, not the same or not parallel to each other. They can be as random as we need them, but they must be on the plane. That's the rule for that form. Will that be okay so far? So it turns out finding normal, you don't have, right? Finding normal from these two is extremely simple. Again, I'm trying to remind you of the basics of plane. Do you know how to find the normal from these two? If you have this dropping.
No.
You just cross product them, no? You will find the normal. Again, you have to do this quite a lot. Can I show you how to cross product now to remind you, or do you need to know why if I cross them, I will get normal?
Yeah, okay, just how to dot product.
Cross, not dot. Cross.
Why are you crossing again?
Which is why I asked you, do you want to know why? Well, the short answer is if I cross these two, I will certainly find the normal.
So cross is the find normal, then dot is the what?
I'm sorry, why are you jumping the gun to dot? You don't know how to cross yet.
No, I know how to cross. I just forget what they do. Like
Yeah.
if you dot two vectors together, what happens?
Let me show you.
You find a third vector.
First of all, when you dot two vectors, you don't find another vector.
Okay, then
Never.
do tell.
Really never. Never. Let me show you as much as I can what a dot product is. Dot product looks like this. Here is a vector which is extremely parallel to another vector. Okay, the length of this vector is 3, let's say, and the length of this vector is 2, let's say. So far so good. They are parallel with each other. So far so good. 3, this vector dot this vector will be equal to 6. It's a simple multiplication if they are parallel. If they are parallel in this way, also 2, red dots blue or red dot this blue, both will give you 6. It's a simple multiplication if they are parallel to each other. The question is, what happens when they are not parallel? So far so good. Ken, you follow me?
Yeah.
So now, what happens when they are not parallel? Like that, this is still 2. Now, when this vector dot this vector, it will be less than 6. Never more. How much less? Well, because this is what it means. No? It will be this 3 with a simple multiplication of whatever this length is. This length is less than 2. So 3 dot this 2 will be less than 6 because it is actually this times this thing. To keep it simple, that's what dot product is. A vector times the shadow of a vector, another vector, along the first vector. Along the first vector. It shows how aligned they are. So to speak, that's what a dot product do. Following me so far? If the the vector with length 2 is like that, do you see how this dot this will definitely be 0? You see how they will definitely be 0?
Yeah.
Because the length of these 2 along 3 is, well, it's nothing. It's nothing. 3 times nothing. 3.2 in this case will give you a 0. They are not aligned at all. They are, well, perpendicular to each other. Look, this dot that will be 0. That's the dot product. Daniel, you asked for this, okay? So do you want to know the cross product one, or just, simply let me show you what cross product is? This is what you want. This is what you asked just now.
Okay, sure.
Okay, just the cross product, okay?
Yep.
You don't want to know, then I also don't want to explain for that part. I think the techniques are just more important. Now, product please. This one cross that. You will have another vector, which means you have 3 numbers to consider. The technique is very simple. For the first guy, cover these 2. Cover it. Like literally using your mind or your pencil, cover it. Look. Then this times this minus this times that. Would you kindly do that for me? If you would do it on Jamboard, that would be very helpful.
You want me to cross these 2?
Yes. Cover this. You want this first guy, right? Cover the first one. And then
Isn't this in the plane?
minus this times that.
I thought I was supposed to not cross vectors within the plane. This is a cross like this and this.
Look, now you're asking me why you want to cross or how to cross. Which one do you want?
Why are you crossing? I know how to cross.
Goodness
I
me.
don't know why you want me to cross.
Because cross product will always give you a vector which is 90 degrees to both of them.
Why do you want that?
Because that's the normal.
Why do you want the normal?
Because you can have this form. And you can ask why do we want that form, right? Because there you go in the back, in the behind.
So this is a normal.
That is always a normal. Yes, if you don't know that, yes,
Okay.
that is always a normal and it's a better form, I guess. It's a better form.
So r dot normal equals, oh,
Hello. Yes.
you're right. Okay.
Hello. Yes. Yes, correct. And we are in the
Yeah.
process of finding that. We're in the process of finding.
So you're not really per se converting the form as much as just finding the normal and then comparing.
I really want to find the normal. Yes, that's the natural. It should be the natural thing to do because that's a better form. It is very useful for most things, right? Very useful for most things.
Yeah.
And suddenly, I'm open to certain other techniques after that. This is the technique, like it's a very simple thing, goodness me, right? Once you do that, once you do that. Would you like to do that in Jamboard or in your own page? That will be up to you, but please, I guess, please do something. Jamboard will be easier for me. That seems to be a very nice normal. Nice. Oh. Wait. Sorry. There's one mistake. There's a simple mistake, right? For the middle guy, it has to be the minus of that.
Oh.
That's just how cross product works. That's the simplest thing I can say. So a plus. There you go.
Wait, so that should be plus 2 then.
Yeah, you can just minus the whole thing.
No, isn't it?
It's not
It should be 1 plus 2. Can you
it's
just check
1
that?
minus 2 and then you minus the result. That's one way to memorize it. So it's minus 1 plus 2 if you want to lah. It's going to be minus 1 plus 2. This is the technique. Please do it that way. I guess that's the simplest thing I can say. Yeah, the middle guy has to flip lah, so to speak. The rest is totally, oh goodness me, this one is also wrong. This guy is also wrong. This guy must be a minus. Wait, what? This guy must be a minus.
Yeah, I'm checking.
Goodness me, this guy must be a plus. Okay, there's a lot of mistake here. Okay, please try again. Please try again.
Okay, so the first one is plus.
Because
the
S
first one is plus. Second one is minus 2 plus.
Correct, something like that. Yep, that's probably how your teacher will explain first. Yep. But the sign is all wrong. So kindly make sure that you know the technique.
Wait, no. This should be S minus 1, because the first one is plus.
Yeah, the reason
times minus 1.
In the cross is this one S lah. I agree. This one is S. This one is a minus 1, but by right it should be S minus of that guy lah. It's S minus 1. Sorry.
So the first one, just go through with me the default. So the first sign will always be minus. Then the second one is minus whole thing. And the inside is a plus.
Yeah, the answer is no, not like that. Not like that. Let me explain one more time the technique. So this is S and this is minus 1. So far so good. That one's okay lah, right? This one S.
No, I'm just asking for this, the one in the center.
Yeah,
so for the first one is always minus. Second one is what? Are they always minus?
So let me put it this way. The guy in the middle is minus, positive, negative. Let me put it that way, positive, negative, then negative, positive, no? Then positive, negative. Maybe I'll put it another way.
Okay. Sure.
Kyoko, I can see you. Can you hear me?
Yeah.
Okay, Kyoko. Now, Kyoko, how are you still burnout, you think?
I don't think so.
Should you work hard this week or should you not? Should you just take it a little bit easy? Remember, the goal is to be fresh after holiday, not just during holiday. Do not be anxious and then start to do stuff just because you're anxious. That is the reason why you get burnout in the first place. If you do that again, things will not improve, you know, when we go back to school. School is still important at this point, you see. Will you get burned out if you work hard this week? If you will, don't work very hard this week. It's still holiday, really.
Okay.
Right? Don't. Like you still have time to recharge yourself. Please do. Please do. Please do. Now, for today, however, you seem to be good enough, yes?
Yeah.
Now, what do you want to do today? Do you want to work out the analysis yourself? Do you want to do something else? Do you want to focus on the polynomial, for example? Like that's what you wanted, right? Like that.
I said it was minus plus.
Yeah. So let's look at it one more time. Yeah. So we get this right. So we do it this way. So this will be your 1, right? And it will be a minus, right? There, guys, the minus now, right? This guy
will bracket
be, there will be a plus.
So there's no bracket lah.
I don't know. Okay, right. So I'll do it this way. So if I treat this as usual, I will treat it as 1 and then minus 2. That's the usual thing that I will do right now. Okay. Usually it's like that one. Am I correct? Is this okay? Yes. If there's no difference with the other, it's going to be 1 minus 2. And then the technique calls you to flip that guy just fully. That's what I did the first. So therefore, yes.
Minus.
Yeah, just put +1. No? If you don't get +1, you're wrong. No? Work it out. You do have to work this out in your mind.
No, because you put minus, you said minus plus just now.
Yeah, it's like this, man. The -2 is sorry. The -2. There, that's my minus plus, man. So this is equal to 1, man. I'm not sure why it is equal to -3 at this point.
You said there was brackets.
Oh goodness. I go with the other method lah. You wanted the plus minus plus method. Now I don't say that again. Now I say do it normally but flip it. Do it normal but flip it. That's usually how teacher teach anyway. Normal but flip.
Okay. Okay.
Yeah, you'll get a lot of practice next time. Now, this is not the end. No, you haven't got the form. there is the other guy to worry about, the guy in the behind lah. This number. You also have to remember how to get this number. For you, Kyoko.
I wanted to maybe do the topical device.
Correct. But which topic? You have to choose. I mean, at most you can do 2 topic in tuition. Outside tuition, you can do whatever you want, but tuition focus on 1 or 2 topics lah.
Polynomials and Hugo.
Then Tigo is a super big one. So why don't we focus on polynomial first? Shall we?
Okay.
Yeah, that's it. Okay, and then I'll follow you using Jamboard. And yeah, do you know how to find the guy behind?
No.
So right now, the situation is this lah. So R dot the normal, I'll put it for you as s plus 1, and then this will be minus 1, and then this will be minus 1 minus 2s, okay? Then equals to, I will just put it to you, whichever. Okay. By right, the method to find D is very simple. You take any point on the plane. You need to know one. You need to know 1 point on the plane. If you just take that point, put it in R. You put it in R, you will get your D. I mean, it is usually as simple as that. Now, do you have a point on
2 minus 1 and 1?
That's not a point on the plane. That is really not a point on plane.
Then I don't know.
The point on the plane, practically, is plus 0, 0, 0. Usually in this form, you will see 3 things, not 2. The guy without the constant will be a point. I mean, isn't this just like the line? Remember the line form? The line is, you know, a point plus constant lah, a vector lah. This is on the line. On the plane, that same thing applies though. If you have a constant in front, that's not the point. The one without any constant in front will be the point on the plane. Do you see anything? Nothing. Or that means it's 0, 0, 0. That actually means that it is 0, 0, 0.
So I make R 0, 0, 0.
And you will get the D. Give it a try.
0.
Yeah. And therefore your D is 0. And that's the last thing we need for the conversion. Now you can write the plane P2 already. Basically write down D, and then now we can do this thing. Now we can do it. Actually answer the question.
One more time. I got positive 1. I didn't get minus 1 for the cross product.
Yeah, do that one more time. Let's do that one.
Okay, I will do it in front of you live, and you can tell me what I'm doing wrong.
Yes.
So just the third one.
Yeah, just do the normal.
1 times 1.
Yeah.
So minus bracket 1 times 1. And then I do it normally, so it's minus 2.
Yeah.
So 1 minus 2 is minus 1.
Correct. And minus
bracket minus 1 is 1.
It's 1. Yes, correct. It is 1. Yes, it is supposed to be. Yeah, it is supposed to be 1. Yes, positive 1.
But you wrote minus 1.
I'm so sorry. That was my mistake.
Oh, I thought I was confusing myself again.
No, that was my mistake. Sorry. In the origin, it was positive 1. Sorry, that was my.
Okay. I think we both confused each other.
I'm so sorry.
Okay. Then, so now that we have both of them, both the normals in the
Yeah,
same form, but this is another one.
yeah. So we have P1, P2, very nice, all the stuff. And then here comes the drawing law. Here comes the drawing law. So I did say that they intersect in line L, right? The line L is the one on top. So that line should be in both P1 and P2. Make sense first? Since the line should be in both the plane 1 and plane 2. Take your time first, make sure that makes sense. Kyoko, are you?
I made the
Yes.
Jamboard.
Yes, I mean. Do you need a you need a review right now, or you can do something already for page 2? If you need a reminder, tell me. Okay, we waste.
Yeah, I need.
Okay, now this is remainder. I'm applying remainder theorem. I'm explaining very short first. If you don't understand, I'll explain longer and longer. Remainder theorem means I will put in -2 into the.
Can you hear me? Sorry. Hello. Phillips, can you hear me? Damn. Hello. Hello. Kyoko, where did he go?
I think she like. I don't know.
His WhatsApp is on the one thing.
Last time he said he got a blackout, so I don't know.
Oh shit. Okay. Unlucky. Yeah, it's a blackout.
Testing. Daniel and Kyoko. Can you hear me, Daniel and Kyoko?
Yeah.
Okay, good, Kyoko. Right. Daniel, if you can hear me. Okay. So Kyoko, I was
Got it.
right. Sorry about that. Blackout happens in Batam, right? I'll be back in Singapore in 1 week. Let me explain very quickly to Kyoko first. So remainder theorem, put the -2 in and you will get the remainder. Ring any bell?
Yeah.
Okay, do that first. Check the answer key whether it's correct or not. Then we continue. Yeah.
Okay.
Back to you. Where are we? The line is in plane 1 and plane 2 lah. So far so good.
Yeah, I've equated the lines. So I found S and Q.
You've you equate.
Yeah.
What does that mean? Sorry.
Basically, they say they intersect at L, what? So they asked me to determine the values of K and S.
Correct. Then what?
Oh, wait, so I answered the question already. S is 1 and K is -3.
Let me confirm. How did you do it? I mean, it's nice. Yes, but how?
I say at L, S, basically the normals equal each other.
The normal.
Then I just write it out.
You can cross both of them. That's one way. But are you doing it? Okay, nice. The non-dum. Now I'm not sure what the normal equal to each other means though.
The normal vectors, what? And at a point they will be the same.
Let me show you what you are saying. What you're saying is something like this. What you're saying is something like this. Before you look at the answer key, so that you know I'm not bluffing. So what you're saying is this is the normal of the first guy, right? This is normal P1 and this normal P2, right? Correct? That's what you're saying, right? So you're saying that the normal of P1 at this point, the normal of P1 is 2, 1 minus 3. That's what you're saying. The normal of P2, you're saying is, in this case, also 2, 1 minus. That's what you're saying. You're saying that both normals are the same. If both normals are the same, then both planes are most probably the same, kind of, either parallel or the same. Are you sure that's what you want to do for this?
They're the same at that point.
Clearly, you're saying that the normal of plane 2 is the same as the normal of plane 1. That means they are no longer different. They are the same. The normal is the same. That's what you're saying. Are you sure you're okay with that?
I guess not.
I wouldn't recommend it also at this point. I don't think we should equate them lah. But we can do something else. We can do something else. We can, for example, say that the normal of the normal of plane one will be perpendicular to the line direction. We can say that. So, dot product equals to 0. That will give you K. You can say the same thing for the second guy. That will give you S. That's one way that you can do it. Yeah, probably another way lah. Does that make some sense?
Mm-hmm.
If that makes some sense, give it a try. You can also check the answer key first just to make sure that your original answer is not necessarily correct. In case I'm wrong, in case I'm wrong, in case you are right. Kyoko, are you okay? That's the remainder theorem lah, in short. So far, so good?
Yeah.
Now, part 2, do you remember how to do it?
No.
Okay, there are 2 ways to do it. The first way, you should know both. The first way is you just do a long division and you do get remainder equals to 0. That's the first way. Do you understand what I'm saying? Long division this with this guy. So one more time.
Oh, okay.
Right, 2x cubed.
Yeah.
5x squared minus 18, and then you long division. You try this one, that's the long way lah. And you should have a remainder 0. The second method would be sub x equals to minus 3 over 2. You should get close to 0. Try both. You will be needing both anyway, right?
Okay.
Daniel, are you okay so far? If you're trying something somewhere, please tell me where. Yeah? Do you want to do the dot product method? Do you want to know another method? Do you have some other method in mind?
I have, I can cross them, I guess.
Yes, you can cross both normal and then equate the cross result with the direction of the line, because that will be correct also.
What's the direction of the line?
The direction of the line is you already found. Remember, you change the line into something which is direction with a direction. So the minus half 1 0 thingy. That's the direction of the line. You found it already initially.
Oh yeah. Okay.
Now that will be the direction. You cross the two normal. That will then you equate that with the direction of the line. That will give you something. Okay, that's the second method. Look. Either way is probably fine. Give it a try, whichever fancy you. You can erase my stuff or you can go to page 4. Probably page 4 better, yeah. I'll just copy the question for you to page 4 in case you want to use it. Okay, Kyoko, are you okay so far? Yeah, this is a revision of your long division lah. So how's your long division? Continue, Kyoko. You shouldn't be surprised by that, right? Kyoko, your long division is not right, yeah? Your long division is not correct. So consider this a bracket, I suppose, can? Was it good? There's a bracket. Then there's a mistake there. Go fix that mistake first. Yeah. Same thing with the one down there. There should be a bracket. You can do it that way, I guess. Should be in this case. So which one do you want? Yeah. So the result should be 8. If you don't get it, you're wrong. Okay, there you go. Nice, 8. Okay. The one below also lah, yeah. The one below is also a minus lah, right? So, right. So instead it should be a 4 here, I think. Should be a 4x. Yeah, should be a 4x there lah. Nice, nice. Okay, Daniel. Oh yeah, doing it there. Sure thing, Daniel. Right. Oh, goodness me, the cross is rather long, isn't it? Oh, I don't like this. Oh. It looks simple, but it's not nice, isn't it? Uh-oh, right. Daniel, careless mistake. You forgot there's a minus there. There's a minus in front there, in front of -1. So difficult to write.
You're right.
There's a minus there. Okay, there, and then let's check the other. Yeah, nah, very nice. I like this one. I like this, and then actually looks fine. I like that. I like this one. I like this one. Yep. Nice, and then looks very nice. Okay, nice.
Okay, it is.
And that should be equal to the direction of the vector lah, right? Oh, okay. So I was thinking that this might be the easier method, but well, obviously I'm wrong, right? I think the other one probably easier, but sometimes we don't know until we try lah. Sometimes we just don't know. Regardless, it's still a correct method. So regardless, right? So that's something.
What, equate it? I think it's possible to equate still. You have the s minus 1 on the bottom, so you can find the s.
Possible. Correct. Oh
You
yeah,
just sub it
yeah.
in the rest.
The s is 0. And no, the s is 1. That's nice. Right?
Yeah.
Useful. Okay, let's try that. Let's try that.
Therefore, k plus 1 plus 2 s k minus 2 s minus 1 is equals to what? Where did I do that? Is it minus half 1 0? That's the direction vector.
Yeah. Minus half and 1 and 0.
Yeah. So I equate that.
Yeah. Nice.
What?
Okay, Kyoko, both method works, right? You learn both because you'll be needing both. Obviously, here it's easier. It's easier for the second method, obviously. But later on, that sometimes you do need long division. Sometimes. So hopefully, both make sense at this point. Can? Okay, now, Patri, do you understand or not? Copy it to the next page. Copy it. You need. Don't save space. Never save space. When you save space, you become very confused. Never save space. Like never. Just never. Waste of time.
Okay.
Daniel, are you okay so far?
Yep. Got the answers.
Okay, nice. What is K? I am curious though. What is K?
Minus 3/2.
Oh wow. Check the answer key, please. Do you have the answer key? Prevent any.
Nope.
Right. And we just okay. At this point now, what can you do? Can you wait for an answer from your teacher? Is that what's going on? Okay, then let's do that. Let's do that. That we know we don't make any careless mistakes. Okay, very nice. Do we need to talk about part 4? I think it's useful. So if you need to, that would be nice. Right. Yoko, do you know how to do part 3?
Is it the discriminant one?
Let's not remember formula. Now, it's very nice for you to have the long division. I'm going to make use of the long division. Yeah? Use that. In fact, no, you cannot screenshot. I'll screenshot for you. Now, here's where long division really shines, right? Going to put there. Now, do you understand that based on your long division, this is equal to, well, 2x minus 3, you know, times the long guy. The long guy will be, I think, x squared plus 4, I'm sorry, plus 4x, I think, plus 6. Am I correct? This is what it means for the long.
Yeah.
I hope that makes sense. Now, when you say one root, obviously, this does give you a root, right? Root number 1 will be x3 over 2, correct? That's what you did just now, correct? He's saying that this will not give you any root. That's what he's saying. No root. Now, if you understand it that way, then obviously discriminant is one way to show it. Okay. I guess that's also the tidiest way of showing it. Do you understand? Okay, then do something to show that this will not give you any root. Right. Daniel, do we talk about
my wrist is killing me. Can we continue tomorrow? Then I can write.
Wait, this is very important. Sorry. What happened to your wrist?
Wait.
Oh, goodness me.
Yeah, didn't warm up today.
No, we can, but
yeah, there's a lesson tomorrow, right?
Correct. At the morning, body scheduling. But what does this mean? If you force yourself tomorrow, will your wrist get worse?
No, I'll sleep it off. It should be fine. It's like a weird feeling. It's like my forearm and wrist.
Okay, please take care of your wrist. Really, please do that.
Yeah.
I'll see you tomorrow at 11.
All right.
Thank you very much. I'll see you.
Thank you. Bye-bye.
Okay, Kyoko, let's do it. Right, let's do this. So Kyoko, okay so far? Part 3?
No, I don't think so.
What do you mean? The discriminant is minus what? What does that mean?
No roots. Okay.
Didn't you just answer the question?
Yeah.
Understand? The one real root is the one before, the one that you actually use, correct? This makes sense? The question is a good revision question. The question forces you to understand all the concepts. You don't get to just memorize, right? You must understand. Are you sure you understand so far?
Yeah.
All the techniques here are the common techniques. That means you do have to know. Again, a very good revision question. Part 4. Part 4 is more like I want to mix topics. I want to mix, well, in this and this polynomial. Do you understand what's going on here?
No.
Then you must see the connection between the new thing, the one within this lah, the new thing and the original equation. If you don't see the connection, it will be very difficult. Now, do you mind if I spoil the connection for you? That's the hardest thing to see, but once you see it, things are easy. Why spoil it for you first? At least once lah this time. Think about it. I'm gonna line them up first lah. One of the best thing you can do is simply line them up. Okay, that's the original.
Is it Px is 0, then if you move the 18 over, it's the same.
You have
as,
18. You have minus 18 lah, correct lah.
Yeah.
Yeah, but that's not enough lah. That is, however, a very good start. You do need to do that. You do need to, of course. So at least I have, some similarity here. That's nice, right? I still need to see more similarities, like a lot more than this. However, I think minus 18 and minus 18 is a very encouraging thing. Now, again, do you see it or not?
I don't think so.
All right, now the connection needs to be like this. In every question like this type, remember, I'm giving you something similar to the original, but it's different enough. This kind of question happens a lot. So far, so good?
Yeah.
The key is very simple. The key is, to put it simple, x is equal to what of the new stuff? For example, the new stuff has some sort of y lah. So the x of the original, must be equal to something, something, something y here lah, because the something, something y is the new guy. The y is supposed to be similar. If you can find this, you are done. That's it. You can answer the question already. It's very easy one. Do you understand what I'm saying?
Yeah.
Do you want me to help you directly or not? Remember, this revision, don't waste time. If you think you cannot, just say yes.
Yeah.
Okay. Now I'm going to find this, correct? I'm going to find this. Now, obviously, this is already very tempting, right? This is very tempting one. It's very tempting for me to say x squared is going to be equal to 2y. And then just work out my x, right? My x will be 2 power y. It's very tempting. However, that's only a start. I have to make sure that it works here also. What I mean is that this tempting thingy, I have to see whether it works on everywhere else. If it works everywhere else, I have found the key. If it doesn't work, I have to think again. So far, so good? Right. So, I mean, can you compare this and this or not? Can you do that? Well, the simplest thing is I will simply use this here lah. Instead of using this here, it seems very confusing. I will use this here. Will this be okay? Okay, and see whether that makes sense or not. So, okay, let's see. 2y cubed, right? Is it actually equal to 3y plus 1? I hope it is, right? I hope so lah. Can you continue from here? This is simple in this from now on.
This 2.
Yeah.
Oh, it's the same.
Or if it is the same, then I'm very happy because I found the key. I have confirmed the key. Do you see how I confirmed the key? Encouraging. Found the key. Confirm the key by, well, doing the easier way lah. By doing the easier way. Okay. And you're happy, I'm happy. At this point, you know that we are on the right track. This is not the final answer. What is the final answer? What do they want? You must understand that that is not the final answer. You found the key. The reason is because they ask you to solve. What does solve mean?
Get Y.
You must get y. But tell me, is it now easy to find y?
Yes.
Then please finish it. Let me see. This is a very good revision. Like very good.
Oh.
What is it, Kyoko?
Oh.
Huh? Oh, goodness me. Look, the answer from the original is what? What is the answer from the original? If you solve the original, that means you are trying to solve the new guy by actually solving the original first. Solving the original means you have x equals to something, right? So what is the original x equals to?
-3/2.
It's not -3/2, it's +3/2. What's going on here? It's not negative, it is positive. You are not sure, you better ask. This one has to be clear.
Okay.
You sure? You understand? It's positive, not negative? Okay, then that's the original, right? Okay, I have my original. My original is supposed to be easier, ma. I solve it even though the question did not ask me for x. I have to solve it because it's easier. Now I apply my key so that I can get my y easily. What is my key?
X equal to power Y.
If that is my key and I apply the solution from original x equals to, is it true I can get my y very easily?
No.
Try. X is 3/2, right? Just put it in the key lah. X is equals to 3/2. 3/2 equals to 2 power y. Can't you do anything about that? Where are you writing? Okay, right. I mean, at least this is one equation, one unknown, right? At least, right? At least, like, this is something. And at least you prefer this compared to the original equation of y. Okay, like, you do prefer this one. The question is, can you deal with this? Can or not? If you say you cannot, I just want to do it for you first because this is not polynomial. This is just in this.
No.
Yeah. You want me to do it? Well, ln is a very good idea. No, really, ln is a very good idea. That's what you're supposed to do. Yes, correct. But it's not ln, no. It's actually not ln. I mean, well, yeah, okay, you can ln it. Okay, fine. You can ln it. You can ln it. That's fine. I would rather log base 2 lah. I would rather that lah. But ln is probably fine. That works. Log base 2 is just easier, but ln it also works. There's nothing wrong with ln. Yep. And we will stop here lah for the exact answer. Yeah. There's no need to press calculator. We also cannot, right? But the point is, this is exact answer, and we can.
Okay.
Now, the last part, I want you to just know lah, because then part 4 makes sense. Now, 1, 2, 3, 4. Any question?
No.
Very good revision of this topic. Let's try another one.
Okay.
your next question, Kyoko? Right. So, same question, Kyoko, yeah? You're still revising, right? So if you cannot, we revise together. Can you do, well, 9 part 1?
Mm.
If you're doing something, I'm waiting for you.
It's long division, right?
Because you have already revised your long division, right? I don't mind. But seriously, did you not learn something else from the previous question?
Mm.
Look at the previous question. Isn't there something similar there? You use your long division, which is fine, I guess, but there's another method that you can do.
This is Tuvalu, an island country home to less than 12,000 people with an output of just $63.1 million, which makes this economy smaller than a lot of department stores. There are individual people in the world that have a larger economic output than Tuvalu, but that alone is not what makes it so interesting. This tiny country is only getting smaller, and its highest very quickly become uninhabitable for its 12,000 citizens as fresh endlessly deal with the problems caused leaderboard for action. According a range of your acre being the big one, the tiny economy has developed support for large container ships, which means getting anything to the country is very expensive for its 12,000 citizens, as you can offset this footprint against climate change. Ren ensures transparent economy.
Okay, Kyoko, yeah. So long division is available for you. I agree. And we sometimes do have to use it, but you know it's longer, right? It's called long.
Mm.
Okay. Now you must understand, remainder theorem and factor theorem is also usually available to you. And you should try that, consider that, correct?
Mm.
That is my message. Long division seems easy, but it's also long, it's also long.
Mm.
Now part 2. What can you do with part 2 then? Oh, Now, Kyoko, what are you thinking?
Because you said, like, in the previous one, after you divide, then you get the quotient and the factor. So,
Correct, the factor lah, right? Now,
yeah,
here's a problem. Here's a problem.
yeah,
What is the problem here?
you don't have the quotient.
No, you don't have the factor. 2x plus 1 is not a factor.
Oh,
How do we know? The remainder is
oh
not.
because, yeah.
So you can long division this. It is a total waste of time because there's a remainder. You cannot do it like that lah. You must understand that there's also concept. That's not something wrong. You really must understand that so that you don't make that mistake, for example lah. Are you sure you understand that you cannot do long division with 2x plus 1 here?
Yeah.
We can long division by something else, but we do not know that something else. That is our problem right now, okay? So we cheat. Just press the calculator first lah. No matter what, your calculator is always with you. Long division is always available, factor Riemann theorem is always available, and calculator is also always available. Use it. Do you know how to use it? Yes or no? Do you know how to use calculator to help you find the factor?
Yeah.
Okay, then press something and tell me what the factor is. I also don't know, you see. I also don't know. Just waiting for your calculator.
X plus half.
Okay, you write down first. This is just your working, and it's not the final answer. You cannot answer this way, like obviously you won't get mark, but you are getting a lot of clue from your calculator, right? You sure it's x plus half? Wait, are you sure about this? So what did the calculator give you actually?
Minus half.
Oh, great. Okay, x plus half. And then the calculator give you plus 1, correct?
Yeah.
1, and then one more. That means there's a one more.
Don't have. Don't have.
What do you mean? Oh, there's a twin. Now this means that there will be a twin. One of them is a square. Is what it means. Okay. You understand? Because by right there's supposed to be 3. In that case, they should actually tell you which one. Never mind. Let's say the calculator don't tell you. Now, is this a clue, a big clue or not? Do you know how to use this to actually, get marks?
No.
Let me show you. Again, this gets you no marks. But to me, this is the best thing ever because it will help me get marks. I don't want to get guessing. I don't have time in exam. Right? I want, if possible, I want to know the answer key first, then I work towards it.
Yeah.
Only in this topic, only in this topic and actually in quadratic is it really possible? Because your calculator actually have the function. Okay. Also in simultaneous equation, simple ones, you can do that also. Whenever I can, I do it. There you go. This is when I can do it. Please do that. Please really do it when you can, right? So now, how to get marks? Now, let's get marks. Very simple. Let's apply factor theorem, right? Factor theorem. F, in this case, 1, correct? F equals 1. Equals to something. I'm guessing it will be equal to 0. Please do the formalities of, writing this thing. You have to write something in the middle.
The equation.
Yeah, equals to 1. You're going to sub x equals to 1 to the equation, right? That's the formality. You have to write that down. Okay, something like that. And then minus 3, right? It's minus 1, right? It's minus 5, right? Oh, it's plus 1. I'm sorry, it's plus 1. Now, does it surprise you that this is actually equal to 0?
No.
Right? Then it will also not surprise you that this seems surprise the examiner that seems to come out of nowhere. Where? No need to say. It's gonna be okay. Soon to be your guess. It's your guess. So that it doesn't look, your teacher knows what's going on, okay? You understand me? Your teacher knows. Of course, your teacher knows that you can press calculator. How can he? And of course, your teacher will know that some will use it, some will not, some will use, right? But he can tell which one used, which one not. What? Just don't make it too suspicious, like using the minus half instead. The minus half will also give you 0. But to be fair, who would guess -1 and -1/2? That's more suspicious one. So use something, present something which is less suspicious, even though of course your teacher know what's going on. Don't make his job as an examiner harder. He's really trying to give you marks. Don't make it harder by using -1/2. Do you understand what's going on? I'm not teaching you to cheat. I'm not. I'm teaching you to present.
Okay.
You understand so far? Need to explain. Now, this is not the full mark. After you get this one, you still have to do something else. The appropriate formality is long division after the first one. You understand?
So the original divided by x minus 1.
Correct. And then you continue from there. Normally, like question 8 also do that. You understand? Question 8 also do that. Okay. Give it a try.
Highly dependent on global oil prices, not because of heavy industry or a lot of people driving. The country is really too small for both, but because almost all manufactured items need to be shipped on small boats all the way from Australia. By the time the small boats get there, they would have burnt an average of 30,000 litres of diesel to make the trip. When massive container ships make similar journeys, they obviously burn much more fuel, but the cost can be spread over thousands of containers. The average ship bringing cargo to Tuvalu carries around 10 containers. There just isn't enough demand or large enough port infrastructure to handle anything more. 30,000 litres of marine diesel can cost $60,000 alone, which is $6,000 per container before including the crew, the maintenance of the ship. For a standard 40-foot shipping container was 15,000 Australian dollars, which is roughly 10,000 balu, is very high, especially when factoring in imported essentials. The country has to get that money from somewhere, and one of its biggest foreign revenue sources has historically been sending its people to work on ships. Tuvaluan sailors have become expectations, make them highly desirable crew members on container ships, but they have their food and accommodation. Tuvalu has they are pegged at a rate of easily from about recently.
Whatever your students want to read and whatever their level of English, the Oxford Reading Club digital
streaming sites in the world, most people would reasonably presume that the .tv stands for television.
Oh. Wait, what's going on here? Let's check it. A little bit suspicious. Oh yeah, you make a mistake. That's why it doesn't work very well. Expecting a remainder of 0, you're not getting it. You make a mistake. In long divisions, there's a lot of sign whether you make a mistake or not. When you feel that you are making a mistake, did you feel that just now?
Yeah.
When you feel it, stopping. Don't stop. It's normal to make silly mistakes in long division. What you have to do is simply find them. If you're not prepared for that, if you're not prepared to find mistake in long division, just skip this topic. Really, no point of it. Just don't be surprised. Oh, there's a just go and find it lah. I can see the mistake already. Take your time and find it. If you cannot find it, not for you.
Widely used
steady, just don't panic and
However,
take your time.
Twitch.tv actually stands for Twitch.tuvalu. Every country in the world has a URL country code. The USA has .us. Australia is really useful for companies that want an entertainment-themed web address. Third-party companies that sell domains pay Tuvalu $5 million a year to offer this extension to their customers, like Twitch. In any regular economy, this wouldn't really be worth billions of dollars. But in Tuvalu, the smallest national economy in the world, this little bit of luck accounts for more than 10%. But the country would be a major tourist destination. It only has one tiny airport, and flights only take place 8 times a week. Most of the time, the country's international airport is used as a football field. Getting there is extremely expensive, and Australia does have hotel or a luxury. Australia and New Zealand's split and cultural heritage is not going to make any difference to their government budget, but it makes a big difference to Tuvalu. The arrangement is not entirely one-sided either. Australia particularly gets a lot out of maintaining this close economic relationship. Tuvalu works closely with the Australian Defence Force to perform maritime operations.
You found it? Wonderful. Yeah. Nice. All right, so what changes because of that? There's something that changed. Yep, nice, nice. So it should be now. Okay. Wait. Stop there, Kyoko. Wait, yeah. You found a mistake. That's correct, right? The mistake is -1 here, right?
Yeah.
Correct, you're correct. But nothing changed here, really. Really? Because they don't become 0, you know. Currently, they are not becoming 0.
Yeah.
Find your mistake again. Don't be so surprised that there's a mistake. Most of the time, the mistake is with the minus thingy. The minus is very confusing. Yes, and so just focus on that, right?
In a strategic part of the Pacific Ocean, and the Australian Pacific Seasonal Workers Program allows Tuvaluans to come to Australia to work, mostly in the cotton and sugarcane harvesting industries. It's tough work, but it's not that different from most of the work done on the island. But it does pay a lot better, providing Tuvalu with yet another source of foreign income and Australia with workers to do the jobs that us regular lazy Australians don't do, water and flowing palm trees. It's important to remember that this is still an undeveloped country. Tuvalu actually lobbied to maintain its classification as a less developed country in 2015, because if it graduated to a developing country, it would lose a lot of the services and program opportunities through corruption or economic mismanagement. Tragically, some of the poorest countries on Earth are the richest in natural resources. On the other hand, does have a solid democracy and corruption is pretty low. It just lacks any of the resources that could make it a developed economy. Even if the economy was managed perfectly, it doesn't have any natural resources, it's too remote to trade effectively, and it just doesn't have enough people to make any industry deal with the problem of it sinking into the ocean. To slow down, and eventually all dredging additional land economy to afford. Palu is probably still but already water supplies, so Crocuans haven't been able to push an industry. Economically, citizens are going to move economic centre. It will just lose their country, will stop. But realistically, that was just an attempt to grab head strongly around. But in the coming decades,
Kyoko, you okay? You found it. Oh, you found yes. That's correct. That's the mistake. Yes. And what change? What changes because of that? Nice, very nice. Yes, correct. And then everything becomes equal to 0, which is what you would expect, right?
Yeah.
Now it's 0. Now you're happy. Now you know that it's correct, which is good, right? Long division, a lot of potential of mistake, but at least you can feel it when something is wrong. Okay, good. So at least you are quite okay with this topic. Long division is one of the most annoying thing in polynomial. If you get it right, you can find your mistakes there, then you're quite okay. Okay. Now, what to do after this?
X.
You say factorize completely, right? So you're right, but do you know whether you should stop here or not?
Probably not.
And why is that so?
Because there's a quadratic.
Yes, but last time you stopped, right? This time, should you stop or not?
No.
Or why not?
Because they said completely.
And no, I'm sorry. This may be completely. Again, how do you know whether it's complete or not? Again, how do you know whether you stop or not?
I don't know.
The calculator already tell you that there's one more.
Okay.
Okay, you're clearly not using the calculator, but I'm saying that of course you should use the calculator for your benefit. Calculator's not giving you any marks, but I think it's giving you a lot of help. In this case, again, should you stop or not?
No.
Then what are you supposed to do? Is it the same as the previous question? then what do you do then? Do it lah. Then do it. Then you do it.
Okay.
Is probably going to need to relocate to other islands in the region or land in places like Australia. The government has maintained that this is the last resort, but it might be a better alternative to losing the community entirely. Okay, now time to put Tuvalu, the world's smallest economy, on the economic 600 of Tuvalu of 600 out of 10 tiny, with no very low debt being pretty strong. Australia and New Zealand's growth, and Tuvalu gets a 10 out of 10. Finally, work abroad, Tuvalu, the smallest economy in the world, an average score of 3.8 out of 10, which does put it all the way down here on the leaderboard, but it's punching above its weight. Thanks for watching, mate.
Yeah, Kyoko, I like this very much. You realize that this is, so to speak, wrong lah. It should be this lah. You realize I like this a lot. I like this a lot. It means you do understand something. And as proven, oh yeah, one of them is a square. You just don't know who. Right?
So I don't write plus half
No.
in my answer.
Yeah, plus half, you're wrong. You must write. Because you have to realize that, oh, plus half is not always correct. It can be 2x plus 1. It can be 4x plus 2. Don't know. It depends on the situation. In this situation, clearly 2x plus 1. Clearly.
Okay.
Which also gives you x minus half, right? Which also gives you that.
Yeah. Okay.
But you seem that you realize it, so no problem. Now you understand what's going on here. So again, you don't get to write x plus half and be correct. You don't. Cannot.
Okay.
Now, you have done part 2 correctly and complete, and part 2 is slightly different from the previous question. Are you confused or not?
No, I don't think so.
Question may not tell you which one is which lah. You just have to find out yourself. That is part of the concept.
Okay.
That is not confusing yet. Now, part 3 is partial fraction. It just continues, but it is actually not a very similar thing. I mean, it's okay lah. Can you do partial fraction or not?
Not very good.
Okay, I will demonstrate to you, but remember, this last part is like the last part of the previous question. They are mixing it with another topic. You should consider partial fraction a different topic because the skills can feel different. If you keep thinking that they are the same thing, then you will feel that the skills are supposed to be the same. I mean, that causes a lot of trouble. Previous question, the last part, different skill, right? Totally correct or not?
Yeah.
And anyway, it's not just in this. The combination makes it more complicated. So you learn something new. You learn how to compare, you learn how to find the key, the format looks very weird, yada, yada, papaya. One more time, partial fraction should consider different. Partly also because in exam, they can actually separate. They can actually just separate it. Okay, so again, are they similar or not? Okay, fair, they are similar, but they are also new skills. Now you're going to learn the new skills. Obviously though, the part 2 will be needed. That's where the similarity is lah. Now I'm trying to demonstrate the difference lah. Of course, yeah, the difference. Let's go to the next page. Okay, so the similarity and the difference. So for partial fraction, first thing first, the numerator over the denominator, right? Is the numerator order smaller than the denominator or not?
Yes.
If it is, then we don't have to long division. You understand? Okay, that part you understand. Again, are you sure that part you understand?
Yeah.
Okay. Then we go to the skill of partial fraction. Once this is settled, then I can partial fraction. Again, nothing very complicated. I'm just gonna write this over. I'm gonna now split this to this, right? 2x plus 1, x minus 1 square, making full use of my second. And then here's the partial fraction thing, I'm supposed to put this to x plus 1. I'm supposed to put this x minus 1, and I'm supposed to put this x minus 1 square. This part, if you don't understand, time to talk about it.
Yeah, I don't understand.
Okay, let's focus on this one first. I think this one and this one, actually, most people should understand.
Yeah.
The A also okay? Okay,
Mhm.
okay. This one understand, so clear lah. That was the easy part, right? Then
Yeah.
now, these two should be considered the same, like one package. They are not separate. One package. Some people don't understand it. Some people just memorize lah.
Mhm.
Memorize the fact that if I see a square, I need two. One with a square, one without. Then people go ahead and memorize. The first guy put a B, the second guy put a C. If you can memorize this without a problem, you don't need to understand. But you must memorize it lah. Now, memorize it without understanding it.
Maybe not.
Okay, now I'll give you three options. I don't think any teacher bothered to explain. I will try my best to explain. Okay?
Okay.
The first option is to simply do this. This is perhaps what you will expect lah. Maybe this is the easiest to understand. Why is this wrong, right? Why is this wrong? I'll give you the second option. Bx plus c will sometimes be better for some people. Will this be okay? Some other people have another confusion. This plus cx d over x minus 1. I give you four options. They are possible, at least in our thinking. We are trying to understand the possibilities and why is certain things wrong and why is certain things correct. Now, I'm giving you this possibility not to burden you, but actually to help you. Are they even more confusing if I write a lot of options?
Yeah. Okay.
Then I'll go it very simply lah. I'll go it very simply. Which one do you prefer to be correct, even though you know it's wrong? It's clearly not the correct one lah. You prefer something else to be correct, right?
The first one.
Okay, the first. Then let me discuss with you why the first one is wrong first. Maybe that will start with that. Okay.
Okay.
Let me show you. I'm going to do the first one here. So look at 4 minus x minus 8. Using the first one, so equals to the next page. So this is from B over, and then this will be B x plus 1. Okay, correct. Now, if I use this one, then it will become like this. Can you follow the next page? Does that make some sense? It will be like that. So far, so good? Does this make sense first?
Yeah.
Yeah, so that's the numerator. And frankly speaking, it doesn't look very, it doesn't look very wrong, right? To be fair, like, you can't really tell whether it's right or wrong. So what's wrong? Why don't I do this, right? Okay, again. So let's, since it doesn't look wrong, let's continue first. Let's see what happened. Right? So again, at this point, I will now make it a different color. Okay, just to make it easier to see. So this is now B to x plus 1. So now this green one will be 2b x plus b, right? And this blue one a, because this will be x squared minus 2x, right? So this will be ax squared minus 2ax plus a, right? So far so good.
Mm.
And then this will be a plus. Now a problem will start to emerge. Okay, a problem will start to emerge. Look at this one. Ax squared, and then this will be sorry, Keiko, you're saying something. Sorry.
No. I thought you asked me to answer.
No. So I'm just continuing what looks correct, like, yeah, what looks correct. So this will be to this. So this will be x, and then this will be minus 2a plus 2b, right? And this is going to plus a plus b. Am I making any sense so far?
Yeah.
Okay. So now, the A will be the easiest thing to find out, right? The A will be easiest. So currently A is going to be equal to minus 8.
Mm.
Okay. Now, if I use this one, I'm sorry, the easiest one is to use the other one, right? I'm going to use the other one here, right? Obviously, right?
Mm.
Find B. So currently B is going to be equal to 4
Mm.
plus 8 equals to 12.
Mm.
Yeah. Will this be so far?
Wait. I thought A is -8.
Yeah, I'm trying to find B. So 4 equals
Okay.
A plus B. Come on, yes, can.
Yeah. Okay.
So hey, again, really, right? So far so good, right?
Yeah.
So however,
That one is wrong.
will this be the same or not? If I actually put in minus 8, right? Minus 2 minus 8 plus 2. Well, will I actually get minus 5? I don't think so, lah.
Yeah.
Clearly not.
Okay.
This does not explain why this is wrong. It does not explain why, but it shows you that it is wrong.
Mm.
And this is not a coincidence once. It will always be wrong one. I'm sorry, almost always wrong. Almost always wrong. Almost always means you shouldn't try lah. If you see this in exam, it's not that you are wrong in the middle. It's not. There's nothing wrong here. What is wrong is the starting point, so to speak. Now, is this enough for you? It is wrong. Do you really need to know why it is wrong?
I don't think so.
All right. Then we go back. Okay. This is wrong. If you happen to do it in exam, you will find out that it is wrong. The question is not that you will have a different answer. No. You will find that your answer doesn't make sense in itself. If you do it properly. So actually, that's a good thing, right? There's a protection against the wrong thing. Yeah. There is protection. It's like the long division, like you will do careless mistake, but there is protection. That's good, you know? Right. So if you do something else wrong, you will also get that protection. It is not consistent one, right? So now, do you still need to know why this thing is wrong, or rather, why is this the best thing, or can you just memorize better?
I think I'll just memorize. But I have seen the BX plus C and CX plus D before, so I don't know.
That's for another form. That's for another form.
I'll
tell you strictly speaking first. I'll just tell you strictly speaking first. Surprisingly, all of them is correct. Very surprisingly. Only the first one is wrong. If you
Yeah.
do this and do that, you will again surprisingly find some sort of answer.
Oh.
Some sort. There is a problem beyond this. The problem presented by this and this is that it is harder to follow up to integration. Whoa, I'm jumping topic.
Sorry. Hard, huh?
Hard to do integration. I'm jumping.
Oh, okay.
This one, which is not the most correct, but it is the easiest to do integration afterwards,
Mm.
which is why it is chosen. There is nothing wrong with this and there's nothing wrong with that. Okay. Wait, to be fair, the last one is more complicated, to be fair. The last one is more complicated. If I could just do this one, I don't want the last one. I mean, to be fair, right? But maybe there's a confusion between the second one and the third one. Maybe. Okay, that's fair. Then I tell you, it's easier to do integration at the third one. So that's a bonus for you. Okay. Turns out what you need is to be convinced that the first one is wrong. Turns out. Okay. Now, if you could, and if you want to, please practice the second form, this one, the correct form by yourself, and then you stop it for today, because it's already 10 o'clock.
Okay.
But could you at least practice it first before you stop? Would that be okay?
Yeah.
Now, before we separate, so from what you're saying, I'm guessing that you should still take it easy this week. Yes.
But I think I'll still be doing some studying, just maybe not very intensely.
Correct. I never forbid you to do something. First of all, it is very difficult to rest without doing anything. Especially when you're burnout. Let me put this very clearly. If you are burnout and you just stay doing nothing, that won't work. Most people cannot do that one.
Yeah.
You're supposed to do something else. You're supposed to be doing something, but not something productive. Like, for example, I'm supposed to work. I'm supposed to learn math, right? But I'm burnt out. I cannot learn math. Okay, then instead of doing math, I learn physics, which is pure nonsense. That's also pure nonsense. You're trying to be productive here. Don't be productive, right? So, can I do math but a little bit? What is bad is you try to do one question and you get stuck for 2 hours. That's really bad. That is not just I'm asking you to not be productive, right? Do something which is not productivity. Okay, well, how do I know? I mean, okay, fine, you just try lah. I do one question, you cannot do anything for 2 hours and you almost just stare there being like a zombie like that. After 2 hours, the problem is you'll feel so demoralized.
Yeah.
Right? And so therefore, don't do that. That is what I'm worried about you the most. Remember back then I teach you how to handle hard question. Just skip. You don't even have the focus to skip. I was very worried at that point. Uh-oh, something is wrong.
Yeah.
Well, people will not find it hard to do that. As in people in normal situation, right? Understand the danger in trying to be productive when you're not very certain. Right? So again, should you do it or should you not do it? There is no real answer until you try, but certainly you should not try for one day. Certainly you will know the answer after trying for half an hour or 1 hour. For example, today, let's just call this tuition a try. To be fair, you get something out of it. It feels to me like you get something out of it, correct? Therefore, you should stop. The moment you get something out of it, you're still a bit fragile, right? Okay? You still feel a bit of burnout here. After, if you get something, you stop. That's the best thing already. I'm asking you a bit more. I'm trying you to stop after you settle then B and C. Do you know what? If you try this and you don't get it the first or second try, what should you do?
Stop.
You stop lah.
Okay.
That's it lah. I don't know where you are, your limit is. You also don't know. Try. First try, second try, not working. Either I don't know something, fair, right? Or I'm just too tired. I don't want to figure it out. Just stop lah. You already get something in a 1.5 hour what?
Okay.
Okay, that's the good thing about trying. That's the good result about trying. The bad result is I try for half an hour, I'm not getting anything. Just stop low. Don't wait for 2 hours, 4 to 3 hours, try half an hour, take a break for half an hour, then try again. No need lah. If you are still concerned whether you're burnout or not, then you don't need to do that. You have to be aware that you are not fresh yet. You have to be aware of that. Okay, first thing first, you understand what I'm saying?
Yeah.
You don't know where you are, but after you try, very soon you will know. Take appropriate actions. Meaning stop lah. You get something, you stop. You don't get something, you stop. Do you understand what I'm saying?
Yeah.
If not, I forbid you to even try. Okay, sorry, you have a question, Jetta?
The day after you told me to rest, the next day I did most of the day, but I did a bit of e-math. Then
Yeah.
it was quite hard, but I managed to do some parts of the question. And then when it was too hard, I just give up. And then
You
I
mean email or
went to
email?
the
You mean email or email?
e-math.
Even email is hard. I mean,
Yeah.
to be fair, you're rusty lah, to be fair lah. But I mean, at that point, you look back for a while. The way you find e-math hard, can you even tell? Is it hard because you forget certain things? Or is it hard because you're tired? Or is it hard because of something else?
I'm not sure. The question was very, I don't know. I couldn't see another way to do it. Yeah.
I don't know how it feels, right? But seriously, I think at this point, stopping is better than trying to continue more.
Yeah.
Right? Or let me put it another way. Let me put it, because I told you, right? You get something, you stop. You don't get something, you stop, right? The point is to stop earlier than necessary. This is not exam. This is not week exam. We don't have exam after holiday. If after holiday you like this every week, you're useless. It's very dangerous. Because after holiday, you cannot stop. Understand? Huh? You cannot stop. You have to continue day by day. Then when do you stop? I mean, you have a tendency to overwork, you know. Therefore, the proper advice is to stop. You want to try something, let's say you try something, right? Could you please just try for at most, even if you're getting something, at most you try for 1.5 or 2 hours. That's at most. And then could you please go out and do something else, please?
Yeah.
Whether with a friend, I would recommend with friends. I would recommend that, really. But if not, please don't stay at home. Please don't leave that to the Friday. Please go out and enjoy whatever.
Okay.
If you really want to, you come back before dinner, you eat dinner at home. If you really want to, you do that, right? And then after dinner, you try for a little bit. A little bit means at most 1.5 hours. You get something, you stop. You don't get something, you stop. What happened Tuesday? I will recommend the same thing. What happened on Wednesday? I will recommend the same thing. Until one day you wake up and you say, I don't feel too burnt out.
Okay.
You only evaluate yourself after you sleep. It's a day-by-day evaluation, and you have more than 1 week. If you just treat yourself well this 1 week, it will pay you back during your school time one, definitely.
Okay.
I don't want to see you when you're tired anyway. Let's flip that. Do you want to see me when you're tired? And then we don't want to see each other when you're tired, right? So why bother, right? I mean, I like seeing you today. You're good today, but doesn't mean that you will be okay tomorrow. No, no, no. Doesn't
Yeah.
mean you're okay on Wednesday if you try to burn yourself too much.
Yeah. Well, this week I have to go back to school.
I know. Tuesday and Wednesday, right?
Yeah.
More than enough already lah. Please lah. Tomorrow just rest lah. Huh?
Okay.
Just take a breathe lah. Just do that lah. And then
Okay.
Thursday and Friday, just do the same thing lah.
Okay.
It's
Yeah.
enough to just you'll get something in school, right? You'll get something, right? Definitely. Especially if you rest, right? You'll get something on Tuesday, you'll get something on Wednesday. That's enough for now lah. No matter what your school say lah. Your school very stressful one lah.
Yeah.
Your mood very stressful. You also an overworked person lah. That's not good. Okay.
Yeah.
Okay. Very long already I complain about you, huh? I'll see you on Wednesday. Okay. Maybe let's not do something extra this week. Maybe just don't. Huh? Maybe no need. See you on Wednesday.
Okay.
Bye-bye.
Bye-bye. Thank you.
Wait, how am I supposed to do that?
With the power-ups. They give us special abilities.
Oh, really?
Go on, eat it.
Are you sure there's not like a...
Down the hatch. Yep, there it is, and all gone.
Whoa!
The Super Mario Bros. Movie comes out of nowhere to be the biggest success story of the year, as well as one of the biggest animated success stories of the ages. In it, a lowly New York plumber called Mario gets sucked into this alternate world with his brother Luigi. And then he must join forces with a princess of the world to defeat an evil emperor called Bowser and save his brother. And altogether, this is a movie that pisses me off more than any other in a long time. See, the video games that I'm a fan of, they're already very narratively and cinematically strong. They should almost automatically turn into incredible films. Yet, one of those films was mediocre at best, and the other was Assassin's Creed. Except without the assassins or the Creed. Mainly, it was just ass. And I don't usually say this, but I wasn't too happy with getting that. Meanwhile, Mario is a game where you just run around and jump and whatever. It should become the dumbest movie of all time, right?
Super Mario in real life.
And yet... Yeah, the Mario movie is a movie that works pretty damn well for many reasons. The visuals are astounding. The comedy is entertaining and funny. It's a pretty well-paced good time based on a property loved by many. But the most remarkable thing about it is how it functions quite effectively for all audiences, even for those who don't necessarily love Mario.
Who the f*** is that guy?
No matter who you are, you can get into this film where it counts. You can be invested in Mario's journey. You can feel a sense of momentum to not be bored. And you can also care at the end when a plumber turns into a Super Saiyan to fight whatever this thing is. And that, my friends, in big part, I would attribute to this movie using certain Mario's narrative structure of Hollywood blockbusters. That structure can include things that don't fit all movies, like IP elements, and I'm a good benefit from. And at the end, I've talked about Hollywood formulas it used to be. While formulas aren't always great, here's a few narrative cheat combinations you should be using to appeal to big audiences. Is that it's the hero's own flaw that sets the plot in motion. Basically, Mario is an aspiring plumber entrepreneur who wants to be taken seriously by others. The problem is that, aside from his brother, the people around him aren't exactly taking him seriously. His former boss is sure that on his own he'll never make it.
You're a joke, and you always will be.
His clients aren't exactly impressed by his work, and even his own family has doubts.
Dad, what did you think? I think you're nuts. You don't leave a steady job for some crazy dream.
Thanks, Dad. That essentially is the character-defining flaw of Mario. He's obsessed with being seen as a real deal, no matter the cost. Whether the cost is putting his life savings in an ad, or whether it's dragging his brother into danger just to prove to the city that he can do things others can't.
And the worst part, you're bringing your brother down with you.
And what ends up happening is that this character flaw of Mario incites trouble in a way that begins the plot. Mario's plan to stop a local flooding goes down the drain, so to speak, after which he and Luigi get pulled into this mysterious pipe, which separates their paths into different worlds.
Nothing can hurt us as long as we're together.
As a result, the adventure begins.
Has landed in the Darklands. I'm taking you to see the princess. She can help.
Yeah, so Mario must save Luigi. In other words, he must undo the consequences created by his own obsession of being taken seriously at any cost. He must rescue his brother from the mess he himself put him in. It's Mario's own flaw that has set the journey in motion. And the reason that's, for example, his own, sure. But not to the same extent. A lot of audiences who don't already know or care about this bond between Mario and Luigi would have a tougher time to invest in the journey.
We don't care. We don't care.
But what each and every audience member of each and every species does know and can relate to is the fact that one's own mess always makes for the most powerful cleanup.
Did you do this to my slipper? What did you do?
Mario is responsible not at sea patent you should be doing, not only to increase investment, but also to make your hero an active person pushing the plot rather than a passive spectator being pushed by the plot. It's just a matter of finding a fresh, organic way to do it. Whether it's Woody's jealous flaw of wanting to be Andy's favorite toy that makes him half accidentally yeet Buzz out the window, or whether it's Ralph's insecure flaw of needing Vanellope as his best friend that ends up freaking everything. Or
now what's key here is that your character's flaw actually comes out of her grand passion. It's a good thing that's just been taken too far. She's gonna have to make a choice on how to deal with her new reality. There's a high road to take, a healthy, responsible choice, or a low road to take and make an unhealthy, irresponsible choice. And remember, if your character chooses to do the right thing, you really don't have a story. So the irresponsible choice for Bob is to lie to his wife Helen and go moonlighting with his buddy Frozone. And that unhealthy choice leads to a crisis, Mirage tracking him down, which leads to Syndrome bringing Bob out of retirement, and you're off into your second act. So that's what I learned at Pixar. And I'm not saying that all stories have to start this way, but if you're writing a script...
Now, of course, the choice is yours. If you feel like you can't find a fresh way to naturally use this cheat code without feeling like you're repeating other movies, then don't use it. Then just make your hero a cog in the world and find other ways to make up for it. But for those willing to dig into your hero to find something to create the story with, you should. Our own mess will always feel more vital to us than someone else's mess. Saving our brother will always feel that much more significant when we know that on some level, we carry responsibility for the danger he's been put in. Absolutely must do it. That is a very effective way to generate investment for a journey.
I haven't been touched in years. But I get it. You think I'm too hard to play? Well, you're doing it wrong. There's an easier way. GuitarTricks.com can
Entertained is that the midpoint completes the first half of the movie and also increases challenge for the second half. Like I mentioned, Mario's main goal is to join forces with the princess to defeat Bowser and save his brother. That is the main objective A. But there's also another objective baked into this, objective B, and that is to assemble an army.
I'm going to convince the Great Kong army to help us. Together, we'll...
First convince the half of the movie progresses, that is what things wind down to. King Kong tells the princess that no, the only way he'll let his army join is if Mario beats his son in a gladiator battle, which Mario
Ini nonton gak ngajak-ngajak. Itu aku nggak diajak. Lagi dia pakai HP ya. Mana? Oh bukan, di lemari baju. Bajunya apa? Sebelah kanan. Belum itu sana. Mau nyalain lampu. Oh, lah ya kasih itu kan. Nyalain lampu, lo nggak dengar. Yang nggak itu. Ini. Iya. Oh ini, enggak. Enggak. Karena kemarin. Enggak. Walaupun enggak pernah dipakai. Bukan, yang tak kasih itu zaman yang dulu banget, Bang. Yang dulu banget.
Agrees to. The issue is that King Kong's son turns out to be Donkey Kong, this really buff monkey character you know from that Evanescence song. There you go. That's the first half finale. In order for the second half of the movie to happen, in order for Mario to pursue Objective A, he must first complete Objective B by beating DK, which is a bit of a hurdle since DK is like, what, 7 times his size. And the battle goes accordingly. As it so happens, Mario then gets this power-up and turns into a superior form of himself, a cat, which allows him to defeat DK. And so he has successfully made the Kong army join his cause. He has completed Objective B, and now he moves on to completing the main Objective A. And the reason this midpoint checkpoint is vital is because it generates a sense of momentum and progression. It's like a mountain in a blank background conveying motion. This is where we're going, and we have now taken a tangible step closer, which is better than walking in place until the third act. Because with younger audiences especially, either you're moving or you're losing to their phones. This can also be done on a smaller scale throughout the way. For Mario to join the princess's trip, he has to first prove himself worthy by showing off his skills on this obstacle course. That's another tangible hurdle in the blank background to convey that we're getting closer to where we're headed. The audience doesn't have to be like little kids in a car constantly asking, "Are we there yet? No. Are we there yet? No." They can see the progression right there. But at the midpoint especially, you should complete a significant portion of the plot to make the audience feel that things are indeed happening and that the needle is indeed moving, which is best done by building a multi-step plot where a part can be fulfilled in the middle. In Force Awakens, the hero's initial objective is just to get Luke Skywalker's map to the Resistance. That's it. It's only after completing this Objective B that they move on to Objective A to join the Resistance's cause of beating the Empire and using the map to find Luke. It's only after Mario has defeated DK that he can have a chance against Bowser. The first half is done, and we're now that much closer to the destination. Another crucial aspect of the midpoint checkpoint is to also make the second half tougher, like with the Empire revealing their big gun to destroy the Republic and isolate the heroes. When Mario has gained the army, turns out Bowser is ready for them, and after a cool Rainbow Road chase, the army is captured, leaving Mario only with DK. As in, whereas in the first half, the plan was to use the Kong army to defeat Bowser's army, in the second half, it has to be done with the help of just one Kong, while everyone else is about to be toast. Or, in the words of the great Michael Bay, just got real. In a sense, think of it like levels in a video game. We've successfully completed this one level, and now we're thrown into this another, much harder level. It feels like we're moving forward and also upward in terms of challenge and intensity. It's all winding down to the final act. Once again, make your own choices, but with modern audiences, a sense of progression and momentum and elevation never hurts. It's just a matter of designing your plot in a way that a segment of it can be completed after the first patch of road in a way that also makes the second patch of road seem that much harder. Do it right, and it's like your movie has just leveled up. code formula here used at the end to make an emotional impression is that the finale takes place not only in the external world, but also in the internal one, or at whale bottom. Mario and DK have been eaten by a whale, while things across the ocean aren't much better. The princess is being forced to marry Bowser, and the Kong army, along with Luigi, are about to be consumed by lava as Bowser's wedding gift.
I'll be sacrificing them in your honor.
Thanks. In other words, the third act begins in defeat, which by itself is helpful because movies are meant to be emotional roller coasters. See, most movies end in victory, and the longest overall distance to victory is always from defeat. The most emotion you can mine is by zigzagging between positive and negative as you ascend from the bottom to the top. That's how you avoid being a straight tonal flatline external battle. Mario and DK fly over to assault Bowser's army while the princess turns the white wedding into a blue one, and then they successfully save everyone from being toast, all of which honestly is very entertaining and awesome. But as awesome as this external battle may be, on its own, it's not enough. In order to really stay with the audience after the credits, the climax has to touch them also on the inside. And that is what ends up happening. Mario saves the kingdom, but also unintentionally brings the battle where everything began, home. Bowser's ship crashes into Brooklyn, and now, much like the external side, the internal side returns to the beginning, to Mario's flaw regarding not being taken seriously.
You really thought you could stop me? You worthless, weak little nothing.
You're a joke.
Seriously, what were you thinking of bringing your brother down with you? Just what I thought.
Yeah, so now Mario's fears about being small are at the forefront once more. And while he does stand up just like in the beginning, this time he's doing so not to show off or to prove himself to the people around him. He's doing it not for himself, but for others. As in, the climax isn't only about the battle on screen, but also about once and for all deciding whether Mario is a tiny, insignificant person or not. And the reason that's vital is because it imbues the fist being thrown with a deeper meaning that audiences can take with them after the fact. The fight is about something. When Luigi gets over his deep fears and joins Mario of his own volition rather than being dragged into it, when they turn into Super Saiyans and destroy Bowser's army as well as him, it's not just about what you see. It also makes you feel that, yes, now that Mario is working together with his brother instead of dragging him along to prove himself to others, that flaw inside him has been defeated in a way that allows them both to fly. That's the emotional feeling generated in you by this climax that you can remember it for. Look, big spectacle is awesome and even required by modern audiences. But at the very end, you should move away from spectacle and armies of characters and just focus on what really matters, bro, and Fuente soldiers. Whether it's Woody learning to see the value in Buzz and working with them to reach home, or whether a brother without thinking before, this is a very deliberate and you can able to delve deeper into this and other proven Hollywood combination formulas and find your own ways of using
Jadi pengen cium pipinya deh.
Baru Nivea Men Vitamin Scrub dengan 100 kali vitamin C dan hyaluron. Wajah lebih segar, cerah, dan halus. Rasakan bedanya.
Makanan hariannya bisa jadi lebih istimewa dengan Whiskas Tasty Mix. Ayam dan sayuran dalam saus dengan 100% nutrisi lengkap dan seimbang. Dapatkan persetujuannya dengan Whiskas Tasty Mix.
So we got some crazy new cards, data mine. coming in the August 20th. They could or not sometime going should be and here in Wolverine's coming out, but it's a claw. He's a 3/4. You're interpowered. Destroy this thing with a truly FB if you're presumably to and that's on 6. Then he doubles the stop port things. Fuel you get more dumping at the perfect road. Lore we do. I actually just auto this. This one's been in the game for a while. 5/3, and on reveal, destroy each card here with less power than this. And that's less than, not less than or equal to. So it's only hitting 2 power or less stuff at a big silver. It's a bunch of brutes. That helped. I've dealt with it, this card so that it's more able to destroy more things. But ultimately, I think it's way too hard to scale up fast. Like a big death, she can't go in between and eat your Bucky and leave your big guy alive. But again, is it really worth spending 5 energy on that? What kind of deck construction does that look like? You know, it's not weird. You can opportunity when this is discarded or destroyed. So again, that dual synergy, regenerate it at a random location, and you get +1 energy next turn. And yeah, I think this looks awesome. This is, we talked earlier about few releases, it just keeps back, bro. It's an interesting thing when, and this guy's a 4/5. With on reveal, each player discards the lowest power card from their hand. So this is actually another potential X23 synergy piece. If this hit us up, Alex Kasson, to hit those pages, they can play it on. It's going to see the most card misses out, and I get it sometimes. I think 3, where it's like you got to have X23. And at number 2, as far as I'm concerned, in cheating 9.